So, welcome to Module 5, Data Analysis. In Module 5, we're going to learn how to analyze the collected data from various concepts related to data analysis. And we're going to look at analyzing this data in terms of threat analysis processing. And we're going to look at techniques for fine-tuning threat analysis and the like. This is going to help us to extract better data, understand the data. It's going to help us to be able to present the data, evaluate intelligence, and create a knowledge base for storing threat information. So we're going to start off with a look at an introduction to data analysis, and then we're going to talk about the contextualization of data and the types of data analysis. So that's what we're going to do. And let's get started. First of all, let's start with an introduction to data analysis. And so with data analysis, we're going to take data, we're going to examine it, we're going to filter it, transform it, and model that data. And in the process, we'll be able to extract useful information. What we're going to find is that in an enterprise, or even in a medium-sized network or company or business, you're going to find that quite a lot of data is generated. And what we need to be able to do in order to present this data cogently is we're going to need to analyze that data and extract useful information from it. We'll talk about this as we go through this module. So data analysis is the process of disintegrating a large data set into smaller components. And then based upon a systematic application of statistical algorithms or logical techniques, we'll be able to break this data down into usable chunks that we can begin to digest using programs and other means so that we can present it and make use of it. Data analysis allows the analysts to build intelligence and to reach effective conclusions to support higher officials in critical decision making. And again, this goes to where the data is going. There are two paths where this data is going to end up. One path is going to be fed into our applications and computational models that will help us to fight threat actors, to fight threats that happen against our organization, its devices, its hosts, etc. But the other fork of this data is going to go to those who need to create policy and understand what are the outcomes of the policy that was previously set. And so we need to be able to present that data to them, management in this case, and stakeholders, so that they can begin to make decisions based upon what we are seeing. So when we look at data analysis, a couple of things that it's closely associated with. Number one is data mining. And what we're going to do is look in a huge data set and discover patterns. We're living in an era of huge amounts of data. And the amount of data that we generate and store is growing exponentially. What we find is that we lose a huge amount of that data, but we do store some of it, and we analyze a fair amount of it. And so we have deep archives of data that is building up that we need to be able to look back into and remove actionable information from those archives. So that's mining, right? We take a huge data set and we pull information out of it that we can use for other activities. And then we have data visualization, where we take a data set and we can present logically and simply a representation of what would otherwise be complex data. This is often done graphically with bar charts and scatter graphs and other types of visual expressions. The next thing we want to look at is the contextualization of data. And this is where we effectively reduce the amount of intelligence into meaningful content. And we do this by excluding irrelevant information. So if you were to take a report that was, let's say, a foot stack of paper and put it on an executive's desk and say, this is what's going on just this week in our network. And how is the executive going to take a stack of paper a foot high and figure out what's going on? What they want to see, better yet, is an executive summary, which is a very small paragraph with maybe a bar chart or a graph. That's it. So what we want to do is take a foot stack of paper or even a meter stack of paper and take all of the data on it and distill it into something that an executive or somebody in a management staff or a stakeholder can make use of. So this contextualization of data improves the scalability and the effectiveness of our intelligence gathering. Because what I can do now is take multiple terabytes of data, and every time I get that amount of data, I can still take it and break it down into usable and presentable chunks. And so I can scale from gigabytes to terabytes and maybe even into exabytes of data if I follow the same methodology. So it helps us to effectively present it. And it helps in keeping meaningful and good quality intelligence apart from loads of gathered intelligence. And not all intelligence that we gather is meaningful. So for instance, if you look at log files, you'll often see where a service started, a service stopped, another service started, a service stopped, and information about some increases and decreases in data that are just normal activities on the system. Whereas if we see 700 failed login attempts, that is going to be statistically significant, and we're going to want to boil that down into a possible type of intrusion, perhaps. So we want to have good intelligence, and intelligence that we can use in order to make decisions. It enables better presentation and understanding of the collected data to threats. So we want to present this data and understand it. Let's look at the 8 types of data analysis that are very important to understand as we get deeper into this section. First of all, we have descriptive data analysis. This looks at dealing with real-time data, current activities that are happening in your organization. We identify what's currently happening. We look at that real-time data, get a snapshot of what's going on right now. That's descriptive. The next one we look at is predictive. Predictive is going to deal with looking at futuristic events based upon the data that you've acquired, and this can help you to perhaps predict upcoming attacks. So we might look at a pattern and say, hey, you know what? It looks like there's going to be an attack coming, and we want to be able to avoid it. This goes right along with diagnostic. Diagnostic data analysis dealing with past events. So we can analyze what happened in the past. And diagnostic data analysis can lead to predictive data analysis. The next we have is prescriptive data analysis, and it comes from the same root word that we use to get a prescription, right? It's something to help prevent something from happening, prevent an illness from happening, perhaps. And so this deals with applying that advanced analytic technique to make specific recommendations. So this helps us to take actions and develop countermeasures before a threat actually happens. The next type of data analysis that we look at is qualitative, and this is analyzing the quality of the collected data that helps determine the likelihood of a threat occurrence based upon non-numeric techniques. And so unlike some of the other techniques that we'll be looking at, we're not going to actually do a mathematical analysis of the data. Rather, what we're going to do is we're going to brainstorm the data. We're going to interview people, talk to people, do a SWOT analysis, use a Delphi technique, etc. So imagine a qualitative data analysis going something like this. We see data, we see patterns, we have a meeting, we're in a conference room, we brainstorm, we talk about what we're looking at. using the experience of the people in the room, analyzing it based upon a verbal exchange, an email exchange. So we're not actually taking the data itself and running it through any type of mathematical equation. So that's qualitative. The next we look at is quantitative, and it deals with analyzing huge quantities of collected data using numerical techniques. So no, we're not using a discussion technique or a SWOT analysis, but now we are using numerical calculations, statistical modeling, measurements, research. We're using mathematical equations in order to come up with that quantitative analysis. Next, we look at exploratory. And what we're going to do with exploratory is analyze the relationships among the collected data elements. And this is going to be really based on assumptions. So what this does is it helps us to find links between data and discover threat-related information. So we have assumptions. In other words, based upon patterns of the data, based upon what we've seen in the past, based upon other types of analyses, we can make assumptions and use those assumptions to leap ahead a little bit and give us some heads up as to what's happening with that data. Lastly, for data analysis, we'll look at confirmatory data analysis. And this deals with analyzing hypotheses with specified precision. And we'll talk a little bit about precision as we move forward. And confidence, we'll talk about confidence intervals as we move forward. What we want to do is produce precise estimates. And so what we do is we do this type of confirmatory analysis using regression analysis, variance analysis, and other statistical methodologies. So there are many different types of data analyses. And now what we want to do is hone in on some of the techniques. This brings us to understanding data analysis techniques. In understanding data analysis techniques, we'll look at statistical data analysis, and we'll look at statistical data analysis tools. Also, we'll look at ACH, or the analysis of competing hypotheses, and ACH tools. And we'll look at structured analysis of competing hypotheses, and we'll look at other data analysis methodologies. So let's have a look at statistical data analysis. What it is a standard data analysis process that an analyst will use to efficiently narrow down the required information from the collected data. And so what we find with any form of data analysis, there is too much data. There is far too much data to analyze. So we have to use techniques that allow us to use the data that we need and to use the techniques that we need in order to get the information that we want out of the process. What we're going to look at is many different steps in this process, including data preparation and classification. We'll look at data validation and correlation. And lastly, we'll look at data scoring in this section. So with data preparation, the initial stage is statistical data analysis, which involves steps like data collection, normalization, and aggregation. All of these are mathematical activities that are meant to prepare our data. Next, we see that during the process of data collection, we have many different sources, numerous sources of data that need to be considered. So we have to ask ourselves, what is the source of data? And we'll talk a little bit more as we get into this, choosing the sources of data and making sure we understand what that source is and if it's relevant to where we're going to be going with our data analysis. And next we look at the collected data being prepared for conducting further analysis. So once we've prepared the data, we can begin the next phase of analysis, and that would be data classification. So after normalization and structuring, the data is categorized. And when we look at normalization, those of you who've taken courses in database, like for instance, MySQL or SQL Server or Oracle, or if you use databases quite a lot, you'll be familiar with the idea of normalization. And what that does is helps to remove redundant data in the database. Now, depending on how deeply you go in normalization, eventually normalization moves out of the realm of being useful for fast data processing in the database, and it becomes more useful for what the human is going to be looking at in the end. So normalization, we'll look at it as removing redundancies and making sure that that data is better able to be handled. And then structuring the data. So we look at unstructured versus structured data. So if we look at unstructured data, that might be, for instance, a lot of email. So if you go into your email exchange, or if you have a Gmail or whatever it is, and download the emails of hundreds of people, this is unstructured data. If we have the emails of hundreds of people and we want to pull from that email, let's say that we wanted to select all email from people with names that begin with JA and end with E, something like that, that were sent between the dates of one date and another date, and that have a possible phrase in it. It's very difficult to pull that type of query from a very large unstructured data set. Can it be done? Oh yes, it can be done. There are many techniques to do it, but it takes a long time. And then the next time we have to perform the same query, it's going to take the same amount of time. Whereas with structured data, where we have tables, and the tables have elements in it like fname, lname, ADDR for address or whatever, and they also have other tables to which they're related that have related information. And so instead of trying to come up with a programmatic query, I can just do a select query. Select star from and do the query that I want to pull that information very quickly from the table. And so within seconds, or in some cases hundreds of milliseconds, you'll have the results that you need. And then the next time you do a similar query or the same query, again you get the results in the same amount of very quick, low time. So having structured data makes it easier to pull information from that data set. So when you think of structured data, think of databases, tables with entity relations, etc. When you think of unstructured data, think of Word documents, Excel spreadsheets, emails that have been sent in between people, just random data. And even it could be other things too, like for instance log files or unstructured data. Unless of course you've taken your log information and structured it. You can actually take your log information and move it into a database table from a log file if you do it correctly. So having structured data makes it much easier to work with that data. So I just wanted to give you kind of an overview of those two terms, normalization, which is reducing redundancies, and structuring, which is to move your data into a form whereby it is able to be very easily queried, and also make it more flexible, expandable too, because we can add more tables and so on. So after the data has been normalized, after it's been structured, the data is categorized, and then we have the similar types of data that grouped together based upon various parameters. And so we can find parameters like indicator type. An indicator type would be IP address, URL, domain, MAC address, stuff like that. Attributes, a language, region, malware type. We also have adversary, which is the organization, an individual, whoever is the entity that is doing the attack, right? We also have incidents or events like time or day or owner, user ID, employee ID. We have relevance, the brand name, the OS, the user. So with all of these different parameters, this can really help us to classify the data. And that can help us to make sure that we understand which groupings the data comes in. Like for instance, if we look at indicator type of a specific IP address, and let's say it's an IP address that comes from a range that comes from a known threat actor. We have attributes. It comes from a region for that actor. We look at adversary. We say, all right, well, that comes from the Underground Hacker Association of Greater North Korea, or something like that. So we know that this is an active group. And we also have the incidents the time of day, the owner. Perhaps we see who they're attacking, what times of day they normally attack. And then we have the relevance. So for instance, they only or usually attack Linux servers of a certain type. So we take that, which is different from another set of classification indicators, parameters, right? And so that helps us to group these different types of data into different groups. So after we have the normalization, structuring, and categorization going on, we have other techniques that can be used for categorization. And one of them is data clustering. And so what we do is we segment and distribute the data into clusters of similar properties. This is what I was talking about a little bit earlier, right? So, we have one group that has these particular parameters, another group that has another set of particular parameters, and then we have hard clustering and soft clustering, where sometimes the clusters have elements of each other in them. Other times they are only using those specific parameters that we've classified earlier. Also, we look at statistical distribution, and these are all the possible values of data in the set, and we'll look at how they're distributed. This is going to be called what we call a normal curve. We'll talk about that in just a few moments. So this is data classification. And next we look at data validation. And here is where we look at the actual validation stage, where we do the mathematical operations to normalize, categorize the data, and make sure that the data is actually valid. And so what we're going to need to do is understand confidence intervals and standard deviation. This is a very important part of data validation. So what we're going to be doing now is we're going to be going into some statistics. The level of statistics we're going to be talking about really requires about a 2-semester college education in statistics. However, we're not assuming that for this class, so we're only going to cover it topically. You need to know that for the items that we'll be discussing, most of this will be handled by your software. So you'll need to understand what you need to do and then take the data and plug it into your software. Now, if you happen to have the statistics that you need in order to run these equations, and maybe even the programmatic basis where you can programmatically put this together, all the better, because it will really help you with working on data validation. But either way, we're just going to do a very high-level overview of these things. So we're going to first talk about confidence levels. Confidence levels are related to the sample size. So let's say, for instance, that you have an orchard of various types of apples. And some apples are large, some are small, some are red apples, some are green apples, some apples have worms in them, whatever it is. We want to take a sample of these apples. And so if you imagine many acres, maybe hundreds of acres of apples, they've all fallen on the ground, they haven't been harvested. We want to find out what is the frequency distribution of different types of apples. What we don't want to do is to go into the apple field that's 100 acres and collect and count every single apple. That's just too much work. And so instead what we do is we want to get a sample size. And the sample that we collect is going to be directly related to our confidence interval. So if I get 4 apples, I really don't have a good confidence interval because it does not really represent enough of the entire distribution of apples that we see in those acres and acres of apples. But if I go and collect a couple of 100 apples, then I have a sample size that can give me a very good confidence interval. And I know that if I run my analysis on that data set, that it's going to be highly representative of the 100 acres of apples. So the confidence level is going to be directly related to the sample size. The next thing that we look at is standard deviation. In order to understand standard deviation, we need to understand the mean. What is the mean? Have you taken a statistics class before? Well, if not, it's no problem because the mean is very much similar to an average. So if you have a data set of 5 values, what you do is you take those 5 values, you add them together, and then you divide them by the number of elements in the data set, which in this case is 5. Right? If you have a data set of 200 values, you take those 200 values, you add them up, you sum them. That's the Greek letter sigma. You sum them, and then you divide them by the number of elements. And that gives you the average or the mean. Next, what we do is we take that data set and we put together the standard deviation, which is based upon the distribution of the bell curve that we get from the data samples. Now, if we look at data samples, we always get a bell curve. So, for instance, let's go back to the orchard and we look at apple sizes. And some little teeny apples fell, some gigantic apples fell, and some medium-sized apples fell. Most of the apples, let's say that the mean apple height is, let's say, 4 inches, right? So the mean apple height is 4 inches or 5 inches. Let's say 5 inches. I think that's even better. Nice, good bite out of the apple, right? So if you look at the mean, that's 5 inches, right? But we got some apples that were 4 inches, and so they're going to be a little bit lower on that bell curve. Some apples that were 3 inches, they're going to be a little bit lower on that bell curve, et cetera. And normally you'd use a finer grained measurement, but just to show you that we have different samples, not different samples, but we have different sizes or different values that eventually give us this bell curve, right? And so we establish an upper limit and a lower limit. We talked about that before for confidence intervals. And that bell curve gives us an idea of the distribution of elements. So the idea of a standard deviation is how that data is diffused. And we have a bell curve that's really narrow. We have a very small standard deviation. We have a bell curve that's really wide. It's a very wide standard deviation. And what we do with standard deviation, if you look at it, it's going to find the variance from the mean. So if you look at the mean, let's look at this slide here. If you look at the mean and go just a little bit to the right and a little bit to the left, we have the first quartile, which is 1 standard deviation from the mean. Right? Then we can get multiple standard deviations away from the mean, eventually giving us irrelevant data. And so, for instance, going back to our orchard, if we look at the idea that we had in the entire sample size, maybe only 1 or 2 gigantic apples, and maybe only 1 or 2 little teeny apples, and those don't represent the sample size, do they? So often what you'll do is, once you get a certain level of standard deviations beyond the mean, you throw away that data. However, in science and in other areas, we look for what is multiple standard deviations out, because those can sometimes be very interesting. You have all the average stuff, and then you have something that's really strange as an outlier, and you'll look at that information. So standard deviation, mean, bell curve, all that stuff, very important to understand. If you want to know more about this, because I'm really only doing a topical explanation, please feel free to pause, go to YouTube, watch a video on it. There's plenty of information out there. So the next one we want to talk about is data correlation. Data correlation is going to give us the relationship or the link between data sets. Right? It's going to describe the interdependency of those data sets. And it's also going to give us the conditional probability based on that data set using the formula that we see down here. And if you are familiar with set theory, if you've ever taken a set theory class or understood sets, you see that we're looking at 2 different groups or groupings here. Group A on the left, group B on the right. And what we see is that we have a intersection between the 2. So we have attributes in group A and attributes in group B, and the intersection between the 2 is where those 2 groups have the same attributes. And so we see here where it says that group A represents percentage of probability of event A occurrence, and B represents the probability of B occurrence, right? And where A intersects B, we see that we have those probabilities intersecting each other. Now let's look at some other data correlation techniques. And these are some statistical techniques that are very useful in correlating data. The first one we want to look at here is Pearson's R correlation coefficient. So in statistics, the Pearson correlation coefficient is often called just PCC. Sometimes you'll hear it referred to as Pearson's R. And if you're in a statistics class or in a physics class, depending on what level of physics you're in, you often hear it referred to as a bivariate correlation. And so given two variables, X and Y, it's a measure of the linear correlation between the two of them. Statisticians, scientists, engineers use the Pearson's correlation coefficient quite a lot, and especially scientists and statisticians. It was developed by Karl Pearson. The idea actually came from Francis Galton way back in the late 19th century. And it's a covariance of two variables. And by the way, the term covariance is also loaded with statistical mathematical meaning too. We take the covariance of the two variables and we divide them by their standard deviations. So you can see that right here. The two variable covariance are up on the top of this equation. And we have the standard deviations in the bottom that we divide them by. And helps to measure that degree of association. The next one we look at is Spearman's rank correlation coefficient. And with Spearman's rank correlation coefficient, it is derived by a couple of different things. Number one is Charles Spearman is one who invented it. But also we see that it's denoted by the Greek letter rho. So that little letter that you see here on the far left side, for those of you who haven't been in mathematics a whole lot, that's rho, right? So often you'll hear it referred to just as rho if you're in statistics. So this coefficient is a non-parametric measure, and it measures rank correlation. So rank correlation itself is a correlation of statistical dependence between the rankings of two variables. What is its purpose? Well, it is there to assess how well the relationship between the two variables can be described using what's called a monotonic function, which is another mathematical can of worms. But either way, what we see is it gives us that degree of relationship. So that's a Spearman's rank correlation coefficient. Then we have Kendall's rank correlation coefficient. Good old Kendall. So what it is, if you look at it, it's referred usually as just Kendall's tau coefficient. And if you look at the actual equation, you'll see there's a little tau over here, the Greek letter tau. And with Kendall's tau coefficient, which was put together by Maurice Kendall back in 1938, so fairly recently, it measures the ordinal association between two measured quantities. And what people often call it when we run the Kendall rank coefficient correlation is a tau test. Let's do a tau test on it. And this is also a non-parametric hypothesis test for a statistical dependence based on that tau coefficient. It's a measure of rank correlation, and rank correlation is the similarity of orderings of the data when ranked by each of the quantities. So again, an ordinal relationship between these two variables, non-parametric. We see the equation right here. So if you need to stop and study each of these and make sure you understand how to use them, actually, it's a good idea to understand what they do. You don't need to know actually how to use these. You know why? Like I was saying before, you're going to end up making use of software that's going to do this for you. So the final stage of traditional data analysis, we're going to score the data based upon the high value of threat parameters, including things like damage level and occurrence rate, right? So what we're saying is if there is a high damage level based upon whatever element we're looking at, that parameter indicates a very high damage level, or it's happening a lot, right? These things are starting to stand out. In that case, I want to score this data because it really needs to be brought to the fore. And so it helps to identify which of the threats are more important. Yeah, this thing is really taking out a lot of servers. This is one that happens all the time. We need to make sure and pay attention to it. This is important. This is harmful. This is something that we need to focus on, so we are going to score it high, right? We don't want to ignore this data. And you can perform the data scoring by implementing graphing and charting techniques, right? So we make a chart. I remember when I first got my first management job, I was working for a company, and this company, I was hired into a pretty low-ranking job in the organization, but I had just graduated from college. It was kind of a recession at the time, so I couldn't get a really good job. But I had already had years of experience in IT. I had a minors and majors, and that really worked in the IT community, but I was doing a kind of a job that wasn't related to it at all when a job was advertised, and I got it. Now I was in management, and I was going to put my college skills to use. And so when it came time to do a presentation, I had these fancy color 3D charts to illustrate the information that I was presenting. And afterwards, I think this happened a couple of times, when I finally got my boss, who was the vice president of operations, he comes to me and says, "Kevin, what I want to do is I want you to get your charts to be simple, okay? If I get one of your charts, I want to take a line and go from the bar over to the actual number. I don't want to have to figure out where it is in 3D. So I learned I needed to make charts and presentations simple enough to present them in a way that people could actually use them. Go figure. So graphing and charting are both very important, but the data that we output needs to be usable immediately by the people who need to ingest that data. So with graphing, we plot the data values into a graph. With charting, we put them into a chart based upon their properties. And so once we've scored the data, we're now able to present it in a graph or chart. You don't have to do this on your own. You don't have to take an Excel spreadsheet and dump megabytes or gigabytes of data into the spreadsheet and then use statistical analysis tools on the data in the spreadsheet and create one of those gigantic, very unwieldy spreadsheets. Have you seen people with those spreadsheets? They're so huge that it takes them 4 or 5 minutes just to load into the computer. No, rather what you should do is make use of a ready tool that is already made to handle data analysis. Let's look at two of them. Now, by no means are these tools inexpensive. However, they are so useful in data presentation that they are very often worth the investment. First one is SAS Stat. SAS Stat is a piece of software that does statistical analysis. It can do variants of linear regression. It can do Bayesian inference, high performance modeling. We see a few of the examples of the charts that it can do. And SAS is one of the highest ranked software companies in the world. And if you look down here at SAS.com, you want to check it out. IBM SPSS, which gives you more advanced statistical analysis, a huge library of machine learning algorithms. And let's stop here. Machine learning algorithms. It wasn't really mentioned for the SAS product, but these days they also incorporate machine learning. Any product that doesn't is not going to be competitive in the future. You need to have some type of machine learning or AI built in to the product so that you can be assured that they're going to be able to use these types of advanced methods in the future, because data is not going to get easier to analyze. So this will do text analysis. Open source extensibility, meaning that if you have open source tools, you can plug them in. and its integration with big data and seamless deployment into your other applications. And so I have a little example of both of these. IBM, I don't know if you've heard of that company. IBM.com is where you can go find it. So SAS and IBM both make really, really good tools for data analysis. All right, let's go to our next section, which is analysis of competing hypotheses. And so with ACH, or analysis of competing hypotheses, we have multiple hypotheses that are collected by multiple analysts. And they're compared against each other. And we have a little competition. And what we want to do in the end is come up with the best hypothesis. And what we want to do is overcome some pitfalls. These are analytic pitfalls. And it helps us to get the appropriate hypothesis and then conduct further analysis. One of the most important things that we'll see in this process is looking at all of the hypotheses, gathering the information, and determining where we want to go from there. So let's have a look at the process of analyzing competing hypotheses, and we're going to go into each one of these to a higher degree. And the first one is the hypothesis itself. So we had analyzed the data, we looked at the locations and the parameters, and we've taken gigabytes of data and pared it down into what we think is going on. It looks to me like this type of attack is coming from this location, and these are the countermeasures and where we should go with it. Well, there's another analysis that says, well, I looked at the data, and to me it looks a little bit different. From my experience, even though it's coming from over there, it's very likely that, right? So we have competing hypotheses that we see. So hypothesis, right? Based on what? Evidence. So we have evidence that comes in for this hypothesis. Then we want to use diagnostic techniques with this evidence, with these hypotheses, and refine it, look for inconsistencies, and then we have sensitivity. With sensitivity, you want to look at the sensitivity of the data that was received and the hypotheses themselves, and then from there we run our conclusions and our evaluation of the data, and then we present that data. So let's start looking at the first link in this chain, hypothesis. So with the hypothesis, we have 4 steps we want to look at. Number 1 is, this is the initial step, right? We start with an hypothesis to begin, where the analyst is going to identify all the potential hypotheses to be considered. So these are going to come from other analysts, right? Or maybe even from software. So depending on where it comes from, we need to collect them. Number 2, multiple hypotheses can be generated either by a single analyst, a group of analysts, where employing multiple analysts from different backgrounds and perspectives allow generation of diverse hypotheses. Have you ever done this? You've been in a room before with team members, and you're analyzing whatever it is. It could be some type of a threat, or it could be just another type of your business, a business activity. You're analyzing, you're trying to figure out where to go, and there are factions in the room, and you're not mad at each other, it's just that you have differences of opinion, and each one says, hey, I think that we need to go this direction. Or I think the cause was this, that, or the other thing. And another group has a differing opinion. Another group has a differing opinion. In my experience, the best way to do this is to accept all of the opinions, no matter how crazy they seem to be. Because some of the crazy opinions actually might help inform some of the more logical seeming opinions. And in rooms like that, we've had people that will come up with ideas. We write them down on large sticky paper and put them around the wall. And then we take a break, we eat some donuts, come back, and then we go over each of the hypotheses that were spouted out by all the people in the conference room. And then we eventually tear down some of them from the wall, we pare them down, put them together, and by the end of the day, after lunch, after the evening break or whatever, we know what we're going to do. We understand where we were because we actually considered everything that everyone had to say. So one of the areas that we want to be aware of in ACH is to consider all of the presented hypotheses. All right, so number 3, they're all collected and screened because we really want to find eventually the best hypothesis. So the screening process is going to eliminate the unnecessary and unproven hypotheses and generate completely new hypotheses that can be worked with in further stages. And so, for instance, there might be a hypothesis based upon a hunch that's unproven. Might be one that is unnecessary. That's a really good hypothesis, but that hypothesis assumes that our environment is only 100% Windows. And as you know, we have a bunch of Linux servers, and we have some Linux workstations, and we have Apple devices also. So that might be an unnecessary hypothesis. Either way, we trim some of those out after examining them, and then we want to make sure that we get the best new hypotheses based upon the data we have. So the analyst must also ensure that the vast number of hypotheses should not be selected, since handling a vast number of hypotheses can lead to uncertainty, which in turn can be troublesome to analyze. So we want to only get the ones that are related to the area, the data, the functionality, whatever it is we're looking at. Now we look at evidence. So this is the next stage in ACH, or analysis of competing hypotheses. In this stage, the analyst will list all the important evidences and arguments for and against each hypothesis. This is the brainstorming session I was talking about before, finding the evidences, analyzing all possible factors that influence the person's judgment regarding hypotheses. And you're going to list all of them. So like I said, we're going to actually hear, we're going to listen, we're going to look, we're going to list them. And some of these might not be hard factors. They might be soft factors. For instance, you might have an analyst that said, I've been an analyst for 10 years. I have analyzed literally thousands of terabytes of data in my lifetime. And every time I see this pattern, even though it indicates A, it's actually B. So they're going to move their hypothesis towards B. That's a factor, right? The experience or the hunch of a person who has a lot of experience. We need to analyze this, and we need to note it, right? The reason that this team's hypothesis is this way is because of this particular item. So as each hypothesis is different from the others, the list of evidence that's acquired also differs in each hypothesis. So each one has different evidence, and the list of evidences helps the analyst either support or contradict in order to make final decisions. So we'll support or contradict the hypothesis that's been given to us. So during the stage, the analyst should possess the capability of imposing his or her perceptions and assumptions and consider deductions of other analyst groups' intentions by comparing all the hypotheses to extract the best one. So again, brainstorming. We're considering it all. We're throwing out the stuff that is irrelevant or non-useful, even though we've considered it and we decide that it's not, and then we eventually come up with the best hypothesis. Next, we look at diagnostics. So this is where we talked about rejecting, right? So we're going to reject a huge number of hypotheses, perhaps, or depending on your analysis, and select the best one from your bunch, your group of hypotheses. And it's going to be done with a look and an eye to all the evidences that have been listed. And so there's going to be a matrix prepared where all the screen hypotheses are around the top and the evidences for the hypotheses are on the bottom. So it's just a little matrix like a spreadsheet or a chart, a table. And then it's going to help you to diagnose the existing hypotheses in terms of evidences and arguments, and allow you to discard the ones that are weak, the ones that are irrelevant, the ones that will not work. And so this matrix, this table, is essential in defining the diagnosticity. How diagnosable is each one of these pieces of evidence, and that'll help us with our analysis. Next, we look at refinement. So in ACH, or the analysis of competing hypotheses, we have refinement, which is a 5-step process. Number 1, we're going to refine that created matrix. Remember the little table we were talking about? And you're going to want to remove the non-diagnosed evidences, analyze any overlooked evidences, and include formulation for new hypotheses, etc. So as you're looking at this, there may be new things that occur to the analyst, and you might want to submit those as new hypotheses. So that refinement of the matrix is the first step. And number two, after the diagnostic evidence, we go through that diagnosis. The analyst has to consider the hypothesis and remove the evidences and arguments with no diagnostic values. All right, we get rid of those. We already talked about that a little bit. Stage three, where an analyst identifies the gaps in previous stages and tries to add additional evidences to prove hypothesis wrong and eliminate unmatched hypotheses. So again, we're going through a sifting to get rid of hypotheses that are not going to be working for us. And then stage four, you're going to combine multiple hypotheses with negligible or no evidence values that distinguish them. And then five, you're going to document it. So, we talk about looking at hypotheses that really are not relevant to where we're going to be going, to our overarching hypothesis that we're going to come up with, right? So we have these other hypotheses that we have with negligible or no evidence. Are we just going to write them off? Are they going to disappear? No, those two are going to be in the documentation. In the documentation, we need to know where the analyst was coming from, where our analysis came from. And so we need to know both what we came up with, our new hypothesis, based upon all the evidences that we saw before, that shook out of the matrix that we were talking about before. We'll see some of this in the lab. And we also want to see where we didn't go and why. Why didn't we choose these hypotheses? And document that also. So that needs to show up in the documentation. Now we look at the idea of inconsistency. This is the actual stage where we reject inconsistent hypotheses. And what we want to do is draw tentative conclusions related to the hypotheses based upon those consistency levels we're talking about before. And then we're going to use that evidence, that information, to reject hypotheses, try to prove them wrong. One of the areas of science that is very important is to try to prove theories wrong. In fact, if you have a theory that everybody believes and it's proven wrong, that's a win in science, right? To prove something wrong is a great win. I see this all the time when people are testing, always testing to see if Einsteinian physics works, for instance. Recently, there was a launch of 3 satellites in a constellation by one of the European launch agencies. I think there's only one European launch agency. Anyway, the 3 satellites were put into orbit, and they got put into a bad orbit. And instead of just feeling bad about the fact that all these satellites are in a bad orbit, they said, hey, wait a minute. Since they're in a bad orbit in relation to the other satellites, we can use that to look at gravity. And they tested some Einsteinian functions, and they proved him right again. So they were able to do that. We want to either prove right or prove wrong. Same in science. We want to do the same thing with our hypotheses here. And so we're going to try to prove them wrong in the inconsistency step. All right, the next to last one that we look at is sensitivity. So in this stage, we want to do a sensitivity analysis to draw our conclusions. And what we're going to do is go through our arguments and evidences and double check them, reevaluate them, revalidate them, and analyze the sensitivity of the conclusions that we've drawn, looking for wrong or misleading evidences. Then we see that this stage is very crucial. And the reason why is one wrong evidence or wrong assumption or hypothesis can completely ruin the analysis output. You may have seen this before. You're looking at the news and it says this nutritional supplement is healthy for your heart. You should take it. And then a couple years later, you see another report that says the same nutritional supplement does not provide any value to your heart. Then 2 years later, this nutritional supplement is healthy for your heart. And each one of these is based upon studies. I've looked at a lot of these studies, and when you read them, you find that some of them have wrong evidence. So for instance, the study is based upon a synthetic supplement, not a natural supplement. Or the study was done on people who are in stage 4 cancer. And so it doesn't represent the population as a norm. And so the benefit obviously is going to not be what it says to be. So each of those studies, if you actually look at how the study was done, why the study was done, look at the political influences of the study, right? So if you're looking at a study that is done by a group of people who are lobbying Congress to make something happen, then there are going to be some automatic biases in the study, right? So we might want to throw away hypotheses that are based upon wrong assumptions, wrong evidence, and because they can completely ruin the analysis output. One of the most important books that I was assigned to read in one of my mathematical courses was How to Lie with Statistics. And this is an important book because it shows how your own biases, the biases in the numbers, biases in the way that the statistical analysis is done, all of those can negatively influence the outcome and produce something that's not true. The reason we were assigned to read this book is because we need to know how to appropriately do statistical analyses. Same for hypotheses and assumptions, and so we need to throw away the bad ones, the wrong ones, the bad evidence. Lastly, we have our conclusions. So the analyst will evaluate the hypothesis and draw conclusions that can then be handed over to management for consideration. And we're going to document those conclusions, the relative likelihood of the hypothesis. Sometimes, even after all of the work you go through, the likelihood is actually relatively low. But even so, it needs to be presented. What we really would like to see is a presentation, conclusion, documentation of a very high probability that our hypothesis is correct. And normally that's the case, but sometimes that's not what you get. You have to go with the data that you get in the end. And either way, it's going to help us suggest, or even help management suggest, milestones, changes, and the direction for the future of the other analysis that are going to be made in your organization. So it really helps with your organization's directionality. Tools to use for ACH. PARC ACH helps the analyst to go through the process, takes you through that process to help make a well-reasoned analytical judgment. As you can see, the tool is nice and graphical, helping you to arrange your hypotheses, etc. It's useful for issues that require careful weighting of alternative explanations of what happened, what is happening or likely to happen in the future. It helps the analysts overcome or minimize some of the cognitive limitations that make prescient intelligence analysis so difficult. If you want to have a look at this tool, PARC ACH, you see the links for it down here at the bottom left-hand corner of the slide. I would recommend trying that out. All right, so next we look at structured analysis of competing hypotheses in terms of taking those competing hypotheses and using the structured analysis of competing hypotheses process. And what it does is it helps to split that hypothesis into multiple hypotheses and making them smaller and easier to handle, and helping the analysis be more effective for the analyst. So here we go. We start with identifying a simple hypothesis, then we test it. All right, got it. Good. We're testing the hypothesis, the simple hypothesis. Do we get clear estimates? No? All right, then we test our evidence collection. So go back to where you got this evidence, make sure that the evidence is relevant, is done well, then test it again. Do we get clear estimates? Yes, then let's try now, instead of taking a small chunk, let's increase the complexity and try it again. So this is the SAC, or Structured Analysis of Competing Hypothesis process. This is actually a fairly complicated process, both mathematically and in terms of processing this. If you want to look further into it, there's a lot of information in your courseware. Now we're going to look at other data analysis methodologies. And so we're going to perform this to find useful intelligence from our gathered data to help us get better efficiency in our composite bulk data. So we have lots of data, and there are other methodologies. Each of these involves quite a lot. You can look into each of them as you desire. We're only going to topically mention them here, which is opportunity analysis, which is a detailed review of the usability of the intelligence. What opportunities does it give us? Right? Linchpin analysis gives us the process of creating a logical sequence of events based on assumptions of the adversary's proposed actions or indicators or mechanisms or implication. That's linchpin. Analogy analysis, where we compare with a relevant situation. So we make an analogy, right, to see if it can help us understand better what's going on. The next is the cone of plausibility, which is a scenario-based method. And what we're going to do is make some assumptions, and based upon those assumptions, develop scenarios. We have timeline analysis, and what we're going to do is graphically represent our actions and events, and timeline analysis often works a lot. Some of these often work really well when you're brainstorming. Critical path analysis refers to the project modeling technique. If you've ever taken or worked with project management software, or if you're a project manager, you're pretty familiar with critical path analysis. And what happens is in the project, based upon time, dependencies, endpoints, and milestones, you have a critical path. And anytime you adjust any of the elements in the critical path, it changes the outcome of the project. And this can also be used as part of your data analysis. All right, after looking at these data modeling methodologies, now it's time to have a look at an overview for threat analysis. And let's just get an introduction, and then we'll look at the types of threat analysis. In terms of threat analysis, what we're going to do is we're going to examine, filter, transform. We're going to model all the threat data that we've acquired, and then from there we're going to extract intelligence. So we're moving beyond data into intelligence. Data that can turn into intelligence can then be transformed into something that can be disseminated and acted upon. It's a process where the knowledge of internal and external threat on that information that we find from those threats, it's a process where the knowledge of internal or external threats and vulnerabilities that are pertinent to your organization can be matched with real-world attacks. Right? So we take that intelligence and we say, hey, this is exactly what's going on in our organization, and you can even align it with what's happening in other organizations. It'll help you as a threat analyst to predict, to combat, to prevent possible threats from your organization. And that's what we're here to do, right? It enriches the security measures of the organization with insight into internal and external data, so that internal data, the external data, feeds back into the measures that we do both programmatically and also managerially in terms of the way we change our organization to adapt to threats that are also changing. And we can look on the horizon and find out what threats are coming and change our organization to be ready to meet those threats. Since the definition of threat varies from organization to organization and industry to industry, even the threat analysis is going to vary depending on the requirements of an organization. Are you a manufacturing organization? Well, you're going to find that the threats that face your organization are a lot different than an organization that's running shared services, accounting. Are you an organization that is a consulting organization? Well, that's going to be a lot different than a Fortune 500 IT organization. So we have to always adapt the threat to what type of organization that we're running. So let's talk about a few types of threat analysis. We're going to look at 4 types of threat analysis. The first one is strategic threat intelligence analysis. Now, when we look at these, we'll find that the terminology has already been used in other descriptions. So what we'll do is we'll focus on the part that's relevant to threat analysis when we talk about these 4 different types of intelligent analysis. So number 1 is strategic, and what that does is focus on analyzing the data that's collected from sources like OSINT and the security industry, human contacts. We want to use those to help build our threat intelligence. And so this is really going to focus on socio-political analysis, reading, understanding, looking at political situations, looking at what's going on in society, looking at blogs, information, again, from OSINT. And we're going to look at a meta-analysis of data that comes from white papers and other types of readings. And these are going to be the results of analyses that other threat analysts are running. And so that strategic is going to give us the overview, really, of our threat analysis data. The next we look at is operational. Operational threat analysis is going to be focused on the data that we have collected from sources relating to attacks, social media sources, chat room conversations, in order to build threat intelligence. So what we're looking for is signs of activity. We're looking for events that have occurred that correlate directly to specific attacks. So we're looking more into what's happening closer to now rather than strategic, which gives us more of an overview. And so we want to look and see with an ear to the ground what types of noises is the threat community making. Are we seeing in news groups or posts online, chats, etc.? Are we looking and seeing that there is an uptick in activity, perhaps, of certain types of threats? So from there, as an analyst, you can develop scripts, update those scripts with code, slangs, conduct, linguistic analysis, timeline analysis, etc. What I've done before is look for a specific type of phrase that's associated with an attack and use that phrase to mine email, to block certain types of emails, to block certain types of communications, to make sure that if that phrase is seen, that we can scrape it out and not allow it to affect the organization. And that's done with scripts and other types of programming tools. All right, now let's look at tactical threat analysis. And this is data collected from sources like attack group reports, campaign reports, incident reports, and malware samples. So now we're looking at actual data from the attack, and we're going to use this in order to build better threat intelligence. And so from this, we're going to be looking for the extraction of indicators of the adversary's information, such as things like the MO of the attack or the tools that they're going to be using, or even communication channels, back channels, forensic evasion strategies, because the attacker is very likely going to be trying to avoid all of the efforts of people to stop them, to thwart the attack. And we want to look at that information and load it back into our threat analysis and make sure we understand it. Next, we look at technical threat analysis for our intelligence analysis. And we're going to analyze data from sources like malware indicators, network indicators, email indicators. And this is going to, again, help us to build technical threat intelligence. And so we can use manual or automated. And what we'll find is most of this is automated. And what we're going to do is work manually in cases where automation falls short. And what we'll do with this data, we'll collect the data and we'll look at it only dealing with a short horizon of time because we're looking at actual attacks that are happening. And lastly, we see that we can use that technical threat intelligence, use libraries such as CIF, which is the Collective Intelligence Framework, to extract those indicators of compromise from the data. So we have 4 different types of threat intelligence analysis. So next, that brings us into understanding the threat analysis process. We're going to be looking at several things here. Number one, threat analysis process and responsibilities. Next, we'll look at analysis based on the kill chain methodology. We'll introduce that for those of you who are unfamiliar. We'll talk about aligning the defensive strategies that we have with the phases of the cyber kill chain methodology. And we'll look at modeling, we'll look at threat modeling, we'll look at modeling methodologies and tools, and we'll look at enhancing the threat analysis process with the Diamond model framework. And then we'll look at enriching the indicators with context, right? We want to look at the context for those indicators. And lastly, in this section, validating and prioritizing threat indicators. Let's get started. Now let's have a look at threat analysis. We'll look at the process and responsibilities. So we collect data from internal and external sources. When we do this, it's going to be very important to use a well-defined process in order to analyze the data and then take the security-related actions that we're going to need to implement based upon what we find. So let's look at this process. And we're going to see a couple of different points that we need to emphasize. And we have a little green dot at the bottom left-hand corner over here and a little blue dot towards the middle. So we see that at one point we're going to analyze a threat based upon the kill chain mechanism that we're going to talk about in a few moments. And we see at another point we're going to engage the Diamond model analysis. Okay, so in other words, there is an entire sub-analysis that needs to take place at these 2 points. So let's see where both the green dot and the blue dot work in this process. So let's start with the indicator escalation. So the collected threat indicators that fulfill the prioritization criteria are to be considered in order to undergo further analysis. So we're collecting data, we're looking at threat indicators. Some of those are going to reach the point of escalation. And this is where the little green dot comes in, where we're going to analyze these according to the kill chain mechanism. We'll talk about the kill chain mechanism in just a little while. Either way, what's going to come out of that is we're going to have specific pieces of malware that we want to analyze. We've talked about this a little bit, so I won't belabor the point, but essentially you're going to have your malware analysis lab. You're going to reverse engineer and isolate this malware in your lab, reverse engineer it, understand how it works, what its functionalities are, what files it touches, how it runs, what it attempts to do, and then from there, our blue dot comes into play. In this case, we'll talk about this in the future here. We're going to employ the Diamond model analysis, which out of that, we're going to get an enriched indicator through fusion analysis. And so you as a security analyst is going to characterize all the indicators. You're going to map them with the relevant threat indicators, the TTPs, the attack campaigns, the threat actors that are associated with these types of campaigns, etc. And then from there, we're going to have an escalation of a specific event to a threat dissemination analyst. So the intelligence is disseminated to whoever it is, the appropriate stakeholder that we've already defined in our threat escalation protocol, or the TEP, for further analysis, right? So we escalate this event, we give this to our threat dissemination analyst, and then the last part of the responsibilities that we have, and we're going to always end up in this area as a threat analyst, that is to document the findings in the threat intelligence portal. So we take the indicators, we've analyzed those indicators, we document them formally in a process that's well known to our organization so that we can make that threat intelligence and knowledge dissemination, putting it together in a portal, make it frictionless, make it easy to do. What happens over time is we develop not only a method of reporting what we've documented to the appropriate authorities, to the stakeholders, but we also develop a knowledge base. And using the appropriate software, we find that that knowledge base can be very easily searched. And so as any type of new threat comes up, we can search the knowledge base first and make sure that we don't already have a solution for that specific threat. So there are many reasons why we want to document it and make sure that we have a process that is very easy to follow for the analysts in terms of documentation. Now we look at a very important aspect of threat analysis, and that is the kill chain methodology. If any one stage in the kill chain is mitigated, then we can prevent a threat. So that's why the kill chain methodology is so important. Because if we can just break a link, we can stop the threat. An analyst must understand each and every phase of the cyber kill chain and must perform the threat analysis based on the phase of the kill chain mechanism to eliminate the threat at those stages. So we have to make sure that we, number one, know and understand the kill chain. Number two, use that understanding to kill that threat at the appropriate level. So what is the kill chain? That is reconnaissance, weaponization, delivery, exploitation, installation, command and control, and actions on objectives. So what we're going to do is have a look at each of these phases and talk about them, and then we'll talk about how to analyze according to the kill chain methodology. So number one, we have reconnaissance. In reconnaissance, we're going to see that there's an analysis made on information, and we're going to usually see this happening in terms of scanning, looking at all the organizational assets, and get information on vulnerabilities, like for instance doing vulnerability assessments. There are many different scans. You'll see some of this in the labs where we can do vulnerability assessments. We're going to be looking at event logs. We're going to analyze those logs. Again, on the side of the defender, we want to be able to find signs of the threat actor in the infrastructure. We want to make sure that the security infrastructure, like firewalls, intrusion detection, intrusion prevention, SIEMs, that they're properly configured and established. We want to make sure that's all there. Why? Because if we can sense the reconnaissance and block the potential threat actor, then we can potentially stop the actual threat in its footsteps. Next, we look at weaponization. And we want to capture payloads, analyze them, extract crucial intelligence information like the exploit that's being employed, malware details. We're going to move to our malware lab. We're going to look at hashes so we can know exactly what malware we're looking at, what files were changed or not. We're going to look at file names and develop a threat profile. Why? Because if we can stop the threat at weaponization, then we have potentially neutralized the threat by stepping in at this point in the kill chain. Next, we look at delivery. And so in delivery, we're going to analyze the possible malware delivery routes that can be employed by the threat actor. So what are some of the delivery mechanisms? Spear phishing. A spear phishing attack when we're looking at perhaps attacking executives in the organization. So the attacker is going to send malware through an email, and we as analysts need to analyze all the emails that are received and gather threat details. Because if we can stop the delivery of the weaponized payload, then perhaps we can kill the threat before it becomes an actual exploit. Next, we look at the next part of the kill chain, which is exploitation. And as analysts, we're going to ensure that the security mechanisms like anti-malware, antivirus, anti-Trojan software are in place to detect the executed threat. So there's some type of threat. It may have made it through delivery. And now it's time for the threat actor to run the exploit. And so we need to make sure that we understand all the system indicators, alerts, those details that would tell us that there is a potential exploit. We want to make sure not only that we have anti-malware and antivirus and anti-Trojan software, but perhaps have on crucial workstations, or maybe even all of our workstations, and crucial servers, or maybe even all of our servers, whitelisted executables so that we know that any executable that's running has already been sanctioned by the organization. And maybe if we can kill the exploit before it is completely run, maybe we can stop the threat actor from taking advantage of our system. So what we saw in the first section here, where we have the red circle around reconnaissance, weaponization, delivery, and exploitation, we are going to prevent the threat. We're going to prevent it. What we're going to look at next is analyzing the threat after it has compromised the system. And what this can do for us is reveal crucial information regarding the threat actors, TPs, and we want to get it at the earliest stage possible in the cyber kill chain mechanism. So we want to go as far back as possible, as early as possible, and we want to look at each step in the kill chain. But at this point, the threat has been enacted. The exploit has been run, and now we are to the point of installation. So in installation, what we want to do is perform malware analysis, capture, identify the malicious activity that's been performed by the malware. This will help us acquire crucial intelligence and threat TTPs. So now we are post-exploitation, and we're looking to identify what exactly happened, how it happened, and why. If the threat has gone all the way over to command and control, then we are to the point where we need to perform malware reverse engineering. We want to find the source of the malware. We want to reverse engineer it. We want to capture it. What we're going to do now is we're going to take this intelligence and engineer it into our SIEMs. We're going to put it into our IDSs, our IPSs, firewalls, and other infrastructure so that we can avoid future threats. Lastly, we have action on objectives. So in this case, the threat actor not only has command and control, but now they can proceed to their objectives, whatever their objective is. Like for instance, exfiltration of data, files, personal information, or even doing damage to systems, or all of the above. So at this point, what we want to do is analyze all the malicious actions that are performed by the attacker. We want to make sure that we understand what this threat actor's profile is. So we're going to profile it, we're going to find their intentions, and we're going to mitigate future actions by, again, working this information back into our SIEMs and IDSs, IPSs, and implementing other types of controls, for instance, like two-factor authentication, to avoid this in the future. So that's the kill chain. Let's look at some further features of the kill chain. So now what we're going to do is align the defensive strategies that we've talked about before and a few others with the phases of the cyber kill chain methodology that we just talked about before. So an analyst has to ensure that the organizational defensive strategies that we have put together align with specific phases of the cyber kill chain methodology. So let's look at the phases, and then we're going to look at some of our defensive strategies. So the phases that we have, again, are reconnaissance, weaponization, delivery, exploitation, installation, command and control, and then we have actions and objectives. So we have detection that we can do on all of these phases. So where are we going to detect with reconnaissance? That's going to give us our web analytics. And so with web analytics, we can see what's going on in terms of people scanning the system. That's going to give us part of our reconnaissance. I'm sure you can probably think of some other areas that we can use to detect reconnaissance. And so what we want to do is deny that reconnaissance. And how's that going to happen? Well, with a firewall ACL. With an ACL, we'll be able to look at specific patterns and block them. So with an access control list, normally what you're going to do is you're going to look at traffic that's coming into the firewall. ACLs work on routers also, and on VLAN access control lists, on switches, etc. But what we're going to do is we're going to look at a specific IP address, type of traffic, port, and many other factors. And we're going to either block that incoming through the firewall or through the website or router or whatever, or outgoing. So that's the ACL is going to really help with that. When we get to the weaponization phase, we look at detecting it with the intrusion detection system and denying weaponization with our intrusion prevention system. Very often, both of these are going to be on the same device, on the same application, right? So we're going to detect it and then prevent it at the same time. In the delivery phase, we're going to need to have a vigilant user. And how do we get a vigilant user? We have to program them, right? Just like we program ACLs into a router, except for it's a lot more difficult. And to have a vigilant user, we need to have a vigilant staff that is constantly reminding the users what to look out for, how to look out for it, what actions to take, actions not to take, and going through and actually quizzing the users on a periodic basis to make sure they understand what to look for. How many times has a user inadvertently clicked on an email link, a chat link, or gone to a website and clicked on an icon that they should have known was improper? Many, many times. So user training and education, and all of that flows back into policies. So if our policy states that every quarter a user has to take a quiz to make sure that they understand how to handle the latest threats, or maybe once a year, or whatever it is, then that policy can be enacted into actual actions, programs, rollouts to the staff and employees that will help with that. So that one little phrase, vigilant user, actually intimates quite a lot of work to make sure that your users can avoid so many different types of threats. Well, also we have some automated means that we can deny, which is proxy filters, right? So with proxy filters, whenever you see the term proxy, that means that we terminate connections and then we reconnect at from another location. So for instance, a reverse proxy, if an employee needs to get to software that is inside the intranet, they'll go to the proxy server and connect to the proxy server, and then it will proxy that app connection to the intranet server. So that would be a reverse proxy. A forward proxy, or just a regular proxy server, would take a user that's on the intranet, and when they're trying to contact an internet site, it will terminate the contact of that site at the proxy server, and then it will reinitialize that connection to the external site, and then it will broker that connection between the site and the user. So with proxy filters, we can filter out any malicious links, malicious software, etc. Right? Also, we can disrupt at the delivery phase with AV, right? Put antivirus on that desktop. So yes, the user wasn't vigilant, but as soon as they clicked that link, the antivirus software went into action and blocks it. Next, we go to exploitation. And with exploitation, again, just like with weaponization, one of our main methods of detecting it is our intrusion detection system. How do we deny that exploitation? Well, that is through patching. Patching is very important. And here's why. Because any operating system or app that has a well-known exploit is vulnerable. And if it's well-known, that means that there is more than likely a patch for it. And so any user or organization that has not done their upgrades, run the patch, they're going to be vulnerable. So if that user in the delivery phase clicks on a link, runs an executable, and it's not caught by the antivirus software, that executable may not be able to function if the vulnerability that it's trying to exploit no longer exists. And then that takes us to disruption, right? And so we see with delivery that an antivirus can help with disruption, but with exploitation, one of the ones that we can possibly do is at the CPU level with data execution prevention, which will block certain types of activities at the CPU level. Next, we look at installation. And installation, our detection, again, is going to be with IDS. And we've already gone beyond delivery. So again, we go to antivirus to block that installation. With command and control, IDS, in order to detect. But denial would come through firewall ACL. So if in our research we find that certain command and control is done through specific ports, we can block the use of those ports at the firewall or at the router through access control lists. Next, we look at disruption. So if a threat actor has set up a command and control network, we can disrupt it with intrusion prevention systems. So the detection system will detect it, and the prevention system will then prevent the threat from being actualized on the system. So with command and control in the degrade phase, we also have a tar pit. What a tar pit is, you can use an SMTP tar pit or an IP tar pit. It's made to slow down the actual connection, the execution, whatever's happening in your command and control network that your threat actor has set up. And the tar pit can give your other tools time to work or allow the alerts that have been previously generated to be acted upon. When you think of a tar pit, think about a giant black pool of tar, and the threat actor is slowly slugging through it because it's so thick. Right? We're trying to slow them down. And then lastly, in command and control, we can use DNS redirects to help to deceive that command and control network. So they might think that they are hitting the right IP addresses, but instead we've spoofed them using DNS redirects. All of this to slow down, confuse, deceive, deny, disrupt that command and control network. All right, so if we've gone beyond command and control, and we have the threat actor already working on their actions and objectives, really all we have to detect is the audit log, unless they've deleted everything, right? So the audit log will show us some of the action that they've been taking. What we hope, though, is all the actions that they're taking to accomplish their objectives are not being done on our actual systems. They're being done on a honeypot. That would be nice. That would really be one of the areas that we'd like to deceive the threat actor. And if they're in the honeypot, then we can record their actions. The honeypot has some tar pit-like capabilities because it's actually slowing down the threat actor and allowing us time. So very important to keep this specific table in mind, and each one of these, detect, deny, disrupt, degrade, and deceive, relate directly to the phases of the kill chain methodology. So we want to make sure and follow them. Now we look at performing threat modeling. So this is a systematic, procedural method to identify and analyze threats. And we rank them according to their maliciousness and their risk level. And what it's going to do is it's going to allow you as an analyst or me to understand that profile that we're talking about before, the threat actor. So what it's going to do is it's going to allow you, the analyst, or me, the analyst, to understand the threat actor's profile, the threat actor's methodology, and help that analyst to create countermeasures. So what's this process that we're talking about? Number one, asset identification. We're going to look at each of these in detail. So right now I'm just going to go through the process quickly. Asset identification, we're going to look at system characterization, system modeling, which is going to take us to threat determination and identification, then to threat profiling and attribution, and then to threat ranking. From there, again, like most of these end, we're going to document it, right? So we're going to do threat information documentation. All right, so now let's look at each of these individually. And the first one we want to look at is asset identification. Now, with asset identification, that makes sense, doesn't it, in terms of threat modeling? If I have an extremely expensive Taylor guitar in my house, and I have very expensive recording equipment and equipment for other hobbies, those are going to get much more attention and listed on an asset list, aren't they? However, a plastic plate, that may not be listed on an asset list. In the same vein, any organization is going to want to identify all their assets. What is important to the organization? And this will help us decide what we're protecting. So we have to look at it from the adversary point of view. What are they going to be after? They're not going to be after the plastic plate. They're going to be after the $10,000 item or the $100,000 item. In your organization, they're going to be after assets that are worth the most. Next, we look at system characterization. So we're going to characterize system looking at the architecture overall of that system. And we're going to have information gathering that's going to happen at this stage, and we're going to identify specific areas that might need to be addressed. So here are some of the steps that we would perform at this stage. Number one, identify the data flows. Now this is very important. We'll talk about DFDs in just a little while, data flow diagrams, but we want to identify where the data is going. And your organization should already have a fair amount of this already mapped, but we'll talk about that as we move further. And then identifying trust boundaries. When you are sharing information with other organizations, within your organization, you are allowing external entities access to data in any form. We want to identify where are the trust boundaries for that data exchange. Next, we look at number three, identifying external dependencies. And this is really important to put together in your data flow diagram. And we'll see what kind of external dependencies we have in the organization to exchange data. This is going to really work directly with finding where our trust boundaries are and identifying data flows. So number four, identifying external and internal security notes. And this is also very important. I've seen this happen many times when there are inappropriate notations in terms of security for an organization. So in working on the organizational security, for instance, you might find that there is a specific tunnel through a firewall and it's not noted, so you shut it down, and then a few weeks later you find that an executive can't have a meeting from their house because that specific tunnel went to an IP address that was a static IP address on one of their computers at home or something to that effect. So we want to make sure that we know if there are any specific internal or external security notes that we need to be aware of. And then number five is identifying what the application does. And so we want to know what each application in the organization does, each application on specific servers, etc. And a lot of times this can be difficult because there are legacy applications that are on systems. Number six, identifying the technologies. And over time, we'll see a drift in technologies, and we want to identify which ones are being used, which ones are currently not being used. And number 7, identifying the adversary entry-exit points. So given what we already know, where are the entry points? What ports are used? What applications are used? What delivery methods are used? And then number 8, creating a system architecture diagram. And knowing all of number 1 through number 7 and your system itself helps us to characterize the system, create that architecture, gather the information, and know exactly what areas need to be addressed. Next, we look at system modeling. And so what we're going to do in this case is look at that architecture that we talked about in the previous step and observe it thoroughly from the adversary point of view. So we're kind of on the red team here, examining that architecture. And so we're going to decompose the architecture where all these different modules are disintegrated into basic modules based upon traditional areas of vulnerabilities in order to create security profiles. So we're going to look where that data is allowed to flow, and if the data is allowed to flow into a specific area, we're going to break down how it gets in there, what modules, what programs, apps, what systems are allowed to interact with that data. We're going to look at the architecture of systems that are affected by that data, etc. And then we're going to model the system, and we're going to use DFDs, data flow diagrams, and we're going to use PFDs, process flow diagrams. And we'll talk about some of the forms of that as we go on. So that's system modeling. Now let's talk about DFDs. Have you ever worked with a data flow diagram or used data flow diagrams? In engineering school, I remember using DFDs for system modeling, and I remember using these in looking at quality improvement and organizational modeling, and also using them in IT for various purposes. So they're really high-level ways of representing data. We try to find out what are the inputs into a specific system and what are the outputs. And in the case of threat modeling, we're looking at inputs to launch attacks. DFDs are systematic. They're a good way to represent the flow of data in a system process. And whenever we create these types of models, it's very important to make sure that these DFDs, this entire threat modeling system that we're talking about right now, that this is something that takes place on a periodic basis. Because your organization's systems, your organization's apps, your organization's deployments are an ever-evolving and ever-changing landscape. And so just because you've thoroughly mapped everything today doesn't mean that 3 months from now it's going to be a good representation of how your systems are running and interacting. So this needs to be scheduled as part of a periodic review of your threat modeling. So DFDs are helpful to identify threat paths, entry-exit points, and we see how the data flows through a system. Here's a small example. If you look at the slide at the bottom here, is an example of a DFD showing multiple processes in an organization. This is a very high-level DFD. DFDs can be extremely low-level too, looking at even specific modules of an application. But in this case, we see the external interactor through a trust boundary. So this trust boundary could be the network edge. It could be a relationship between an internal and an external entity that are using 2 separate trust systems, and there's a trust exchange that goes on at this boundary. But either way, inside here we have multiple processes. We're going to map how they relate to data processes, and then we have another trust boundary that takes us to our data storage. And so this is very general, but it gives us an idea overall of how we can watch the data flow through these individual units, processes, the data processes, through our trust boundaries to specific items like external and internal items like external interactors and internal data storage. So DFDs are very important. When you're modeling using DFDs, you also want to consider, what about PFDs, process flow diagrams. Have you ever worked with a process flow diagram? Well, I certainly have, in many different ways, both from the idea of checking out how processes flow within a system, a physical computation system, and how processes flow within software, from operating systems to regular software at the dev level. And PFDs are visual representation entities that allow you as an analyst, again, to decompose the processes and look at each process component independently. So in this process, the application or the system that you're looking at is broken down, disintegrated into its basic components, and we can navigate amongst this. And if we're going to create PFDs, we'll be able to analyze the methodology, identification, enumeration, prioritization, risk association in terms of potential threats. And so here's an example of a process flow diagram. And this is a PFD representing the security and functioning of an ATM, right? So we start, and there is a card that's input, and then we choose a language. And then at the language choice, we can choose to put in the PIN, right? And then we put in the PIN, and is the PIN correct? If not, then we check to see if it is wrong 3 times, right? It's only been wrong once, so we can go back and enter the PIN again. Obviously, there are many more things that can happen here, but if the PIN is correct, then we can choose an account type, checking, saving, money market, or whatever, right? And then we enter the account, and then we choose the amount in the account. If you have the appropriate amount in the account, then yes, we can withdraw. If not, then we'll show an error account, overdrawn by $3,000 or whatever it is. And then either way we end, and so on. So obviously we can take multiple of each one of these that we see here, these decision-making points here, and set them up with multiple other processes too, right? So this is just a very high-level overview of a PFD. And we can do this with the inputs that go into our systems to try to make sure that we identify and enumerate any inputs and outputs and through trust boundaries in our systems, so we can get an idea of where a threat actor might interact with that process. The next one we want to look at is threat determination and identification. And so what we're going to do from there is we've modeled the system. We need to identify the threats based on vulnerabilities, based upon weaknesses that exist in the system. So some of the basic tactics for analyzing and identifying threats are using model methodologies like STRIDE, PASTA, DREAD, TRIKE, and VAST. There are a lot of these types of threat modeling methodologies. Like, for instance, there's one called OCTAVE, which is the operationally critical threat, asset, and vulnerability evaluation that's been developed by Carnegie Mellon. And what it's there to do is assess your organizational non-technical risks that can result if any of your assets, we talked about asset identification, are breached. And TRIKE, which we see in this list here, is a threat model that is open source. And it's a process from a cyber risk management perspective. And what it is a requirements model that tries to make sure that the level of risk for each asset that you're looking at is acceptable to stakeholders. So depending on the stakeholder. Also, we see PASTA. Makes you hungry, doesn't it? Well, PASTA is the process for attack simulation and threat analysis. It's kind of new on the scene. It's a 7-step process for risk analysis that's platform insensitive. We'll see that one of the models that we see here for threat analysis is a Microsoft model, but this one is platform insensitive, and it combines an attacker-centric viewpoint for potential threats. And Dread. Dread is a system for assessing computer security threats. Used to be used with Microsoft, but they've since come up with their own methodology. But you'll currently find Dread being used by OpenStack, if you're familiar with OpenStack. And Dread, its mnemonic is damage, reproducibility, exploitability, affected users, and discoverability. And I said that Microsoft has their own version of this that actually falls out of their trustworthy computing initiative that they put together in 2002, and it's called Stride. And their mnemonic is spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. So that's Microsoft's Stride. And then you see this one listed in the list here, VAST, which is the Visual, Agile, Simple Threat Modeling methodology. And what happened with VAST is all of these different models were reviewed, and they looked at some of the issues and challenges that each one of these had, and they made a new model based upon that with the stipulation. There are 3 stipulations. Specifically, number 1, that it has to scale across the entire infrastructure, especially into the entire DevOps portfolio. Number 2, to integrate seamlessly into an agile environment. Number 3, to provide actionable and accurate and consistent outputs for your dev team, for your security teams, and then to be able to take that output and make it usable for executives. And so it's made to be very practical. So that is VAST. So we see all of these as some of the models that we can use for threat modeling. And bullet point number 2 is we use categorized threat lists, which will give us, for instance, network lists, host threats, application threats. And so we categorize them, and then we can use threat trees or attack trees. And what these do is, again, put it in a hierarchical order so that we can make sure that we understand what gets the most focus. In fact, if you look here on the right side of the slide, we see a threat tree. Hierarchical diagram helps us to understand the complete attack methodology, shows us the different levels of attack activities. So we see an attacker here, and at the top we see a shared computer, a logged on session. What can this lead to? A session hijacking attack, or a failed data validation in a form, for instance, which can lead to a SQL injection attack. Or we see unauthorized access is somehow allowed on that system, which can lead to privilege escalation. Or we have data in our browser cache, which can lead to retrieving the user's credentials, which can be used in other attacks. So we look at a threat tree here. That brings us then from threat determination into threat profiling and attribution. And we're going to collect information about the threat actor and build an analytic profile of this threat actor, of this adversary, and looking at this adversary's technical details. What are the goals of the adversary and the motives? These all can be very useful in putting together countermeasures for this threat actor. And so the threat profile can include some of the following attributes. Number 1, a description of the threat actor, the motive of this actor. Number 2, number 3, the intent. What are they wanting to do? Number 4, the capability. What have they been able to do in the past? What are the capabilities? Number 5, ownership. Number 6, target and details in both of those. And number 7, operating methods. What methods are they using? And what is their objective? Number 8 in this attack. Which brings us to threat ranking. And at this stage, the analyst is going to rank the threats that have been identified based on the level of risk that can be posed to our assets. So we want to rank the threats in our bullet point number 2 here according to which one causes the maximum damage to system and resources, right? So some of them might cause huge amounts of damage, deleting data, exfiltrating data, etc., whereas another threat might just deface a website or throw up some type of message. So this helps the analyst to prepare some type of countermeasure against those threats on that priority. So there are many different ranking approaches out there, and one of the approaches is to use a simple formula, which is risk equals the probability of risk multiplied by the damage potential. So whenever I look at the term risk, like I've said a few times before, I always look at risk with a $sign for the S, because that probability multiplied by damage potential is really going to give us monetary potential damages. Let's say that the damage potential is very low because a specific system or action that takes place is not going to actually cause any monetary losses or reputation losses to the organization. So even though it's a high probability, let's say 1,000, you multiply that by 1 or by 0.01 or whatever it is, right? So depending on, actually 0.01 wouldn't work in this equation, but you see what I'm saying, that if the damage potential is low, then even with a high probability, you end up with a lower risk. But if the damage potential is really, really high, because there is a huge asset that can be disrupted, data that can be exfiltrated or whatever, then your risk becomes very high. And we already talked about using threat ranking using the DREAD model. So there are many different ways to rank threats. Next, we look at threat information documentation at the end of any diagram or trail that we're talking about with threat analysts' work. It's always going to be documentation because people need to know. Not only do people need to know, but our machines need to know what's going on. So after you complete the entire process, again, we're going to document. And there are many different threat modeling report templates that you can use with a description, target, risk level, attack technique, countermeasures. All of these we put together into a report. So an example that we see here on the right is the description, injection of SQL commands, target, data access component of some sort. The level is high. The attack technique, the attacker is going to send SQL command to the username field, which they're going to put in the form of a query. Countermeasures. We can use regex, right? Regular expressions to validate that particular field. We can use a stored procedure that uses parameters to access the database rather than having the database be directly accessed. So this is just an example of a report template that can be used. All right, so we looked at threat modeling methodologies before: Stride, PASTA, and Trike. Just a quick overview of those again, where Stride is for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. Oh, by the way, make sure you memorize at least what these stand for the exam. Stride is used by analysts to classify threats, right? It's a DFD-based threat model. When you develop that, then you can check it against Stride. And then PASTA, again, which is a process for attack, simulation, and threat analysis. And it's a 7-stage methodology where we start with objectives, go to scoping, go from there to decomposition analysis, go from there to threat analysis, weakness and vulnerability analysis, look at attack modeling and simulation, and then from there to risk and analysis and management, or RAM. So that's PASTA. We already talked about that. Next we get to Trike, which we already talked about being open source. It models effectively. There's a Trike methodology that helps it to put together a really effective model, requirements, implementation, threat, and risk models. And these are the levels of the Trike methodology. VAST, which is the visual, agile, and simple threat modeling. We talked about that before, really working with that DevOps portfolio. based upon that practical approach we're talking about before. DREAD stands for damage, reproducibility, exploitability, affected users, and discoverability. And if you look down here at the formula for DREAD, which is the risk is going to be equal to damage plus reproducibility plus exploitability plus affected users plus discoverability divided by 5, which essentially gives you a mean or an average and allows you to assess risk, right? So that's a little bit about DREAD. And then we look at OCTAVE, which stands for Operationally Critical Threat Asset and Vulnerability Evaluation. And OCTAVE has 3 stages, which is to build asset threat profiles, identify vulnerabilities for your infrastructure, and develop security strategies and plans. And so those are the methodologies, and we've looked at those before. For any of these that have mnemonics, make sure you memorize them if you're going to be taking the exam. So now let's look at the threat modeling tools. There are some really good tools out there. The Microsoft Threat Modeling tool is really nice. It's a DFD-based tool. We have another one called the Web Request Model Threat Modeling tool. And we have Threat Modeler and many others that help you take all that information and put it into a graphical form. Very nice. A lot of these are easy to use. You really need to have a lot of this information broken down before you can use it in the tool. Another tool is SecureCAD Professional. As you can see with this, you can take the threat modeling tool and give yourself a visual attack simulation. This really helps with mitigation and testing. Another one is EriusRisk. And EriusRisk is a single integrated console rather than using multiple consoles that give you the ability to create threat models, manage your application risk. So Erius is a pretty cool tool. There are many more tools beyond the ones that are mentioned here. So if you are interested in threat modeling tools, just do a Google search. You'll find many more. And depending on whether you are an open source type of person or you want to use one that's been developed by an organization, what you'll find is the open source ones tend to require a little bit more work, whereas the ones that are built by organizations like SecureCAD Professional will come with some type of support if you want them to. Next, we look at enhanced threat analysis process with the Diamond Model Framework. The Diamond Model Framework is actually pretty useful. If you are a security professional, an analyst, you may have already used the Diamond Model of Intrusion Analysis. The purpose of it is to characterize organized threats, right? We want to consistently track them. We want to keep tracking them as they evolve. We want to sort threats from each other and figure out ways to counter those threats. And so we see that it uses 4 basic components. These are often just called nodes or vertices, such as adversary, capability, infrastructure, and victim. And with this model, the adversary is going to deploy capabilities over the infrastructure against the victim, right? So it all works together. And we can use this in order to take the information, sans the adversary, and use that to identify the adversary. So here's some steps that we use to collect data for the Diamond model. So we look at step 1, an analyst identifies malware on a victim machine. So that's step number 1. Step number 2, the malware contains the malware's C2 domain. So we have information now on the malware domain. Step number 3, the analysts resolve the IP address of the C2 domain. We get an IP address, an IPv4 address. Number 4, the resolved IP address reveals the adversary details. So we've done a whois on the domain registrar and got more details on the actual adversary. So the Diamond model can actually be fairly helpful in wargaming what's going on in terms of the intruder themselves, right? So that's one of the tools. So next, we can enrich the indicators that we find with context. This is very important because without contextualization, some of this will just be data that stands out there and means nothing in and of itself. So we have various indicators of compromise. We gather these during various methods of analysis. We get all this data, and it's going to be your responsibility and mine to enrich the gathered data to make it usable by other people, right? We want to make this usable data. We want to make it intelligence. So the enrichment of the indicator process is a process of linking the known indicator information with that of publicly, or in many cases, privately available information, put those together, and we enhance the available data that has to do with that indicator. So it can be enriched, an indicator of compromise can be enriched by linking the details like hashes and IP addresses and MAC addresses with the time in which they occurred, with similar incidences, with adversary TTPs, and we're going to look at those types of indicators, with similar infrastructure, common targeting. So now we take abstract data and we link it with details to enrich those indicators. So we can perform the linking using the diamond model if we want, victim focused. We focus on the victim and we look at the victim information, and this can give us some insight into that threat. We have capability focused, where an analyst will focus on analyzing the capability of the threat in order to determine possible potential victims of the capability as the impact over the organization. So if the capability that's displayed relates to vulnerabilities in system types in our organization, then we can begin to block those systems, system types, applications, etc., because we know that if we can block that capability, then the threat actor will not be able to interact with those systems. Next, we have infrastructure focused. An analyst will focus on monitoring the threat actor's infrastructure in order to extract the details, like infrastructure and technology supporting the adversary. So what are they using? Does it turn out that the threat actor has a huge infrastructure in their quiver of capabilities? What do they have available? For instance, maybe the threat actor is just using a laptop, not a lot of infrastructure. And so we might see that there's a lone wolf or a small team that's behind this threat. Whereas, if we detect that there is a massive infrastructure, the threat actor might be part of a nation state, for instance. So again, this leads us directly to adversary focus. Adversary focus is a direct monitor of that adversary's activities to get details about the adversary, the intent, the capabilities, the sponsors, etc. So that kind of works along with infrastructure focus, but we want to establish the context. Establishing the context makes our data closer to information. Next, we get to validating and prioritizing threat actors. So our organizations are going to need to validate, prioritize the criteria, filter relevant threat indicators. Want to make sure that we are not just looking at obsolete, redundant data. We don't want data that resembles just spam or low-level spyware that would really give a low priority for the organization. We want the more high-priority threats. So security groups prefer to give priority to threats that are more relevant to the business. And every time you spell risk, we use a $sign, right? Every time you spell business, use $3 for the S's, right? Locations, your applications, your regulatory environment, your risk and your threat profile. We want to prioritize threat indicators that will affect the bottom line of the organizations we represent. What are some methods for validating and prioritizing those threat indicators? Those are, number one, risk scores. Kind of talked about this a little bit in the past. We won't spend too much time on it. we can feed this information back into our SIEMs, back into our automation to help categorize, prioritize automatically. But we also want the risk scores for human analysts to help make very rapid decisions about any of the indicators that are happening so we can decide whether to make them more significant. Number 2 is tags for context. Context can be provided to the threat indicators by adding threat and technical tags to identify whether an indicator is an isolated event or is part of a complex attack. So with tagging, every time a new threat comes with that specific type of tag for that specific type of threat indicator, we can accumulate information and data on that indicator. Number 3 is human assessment. And this is going to be something that you will do, something that I will do. And we're going to use that to identify and assess manually in order to take immediate action and remediate the threat. All right. So we get a threat that comes across our desk. We put our eyes on it and we use our experience to say, hey, wait a minute, this is something that needs my attention immediately. Let's work it. So we want to validate them. We want to prioritize those threat indicators. All right. So now we move from threat modeling into fine-tuning threat analysis. In this section, we're going to look at fine-tuning that analysis, removing noise, identifying and removing logical fallacies, removing cognitive biases, and then automating the process, which is extremely important in dealing with the huge amount of data throughput that we have very often. We're going to develop criteria for threat analysis software, and we're going to employ advanced threat analysis techniques. Let's get started by looking at fine-tuning threat analysis. What is it? Well, it's a process of taking all the different parameters that we get. We're going to look at certain of those parameters, and we're going to employ an analysis model to comply with any changing intelligence requirements. I look at it as a sieve, right? We're going to make sure that we're looking at only the information, the data, the intelligence that we want to. And we do that by manipulating parameters, which we'll talk about as we go into the rest of this. And what's going to happen is as we go through that sieve, the output that we're going to get is going to be much better. So we want better performance from our devices. We want better output for our reports. And fine-tuning will help us to get consistency in our analysis output. So from one time frame to another, from one situation to another, we have consistent output. And also for our intelligence products, as we input this information into our intelligence products so that they can be more efficient and consistent. Also to identify and adapt to new intelligence requirements. So if we have a good fine-tuning capability, we will be able to adapt. Let's have an overview of the fine-tuning process. So let's look at fine-tuning the analysis process. Let's start at the very top here. We see that we tune the organization security business rules. So we look at how our organization security is applied, how our business rules are applied, and we narrow them, tune them to get better analysis. And then we tune the threat data design. We're going to look at each of these as we go on, so we're not going to spend too much time in them. But we tune the application design, and then we tune the logic structure for our threat intelligence database. And we see there's a little loop here which feeds back into the application design. Moving down, we see we tune the TI database operations and tune the access paths. And so once we tune our access paths, then we need to go back and review our operations. So we see a loop there also. We next need to tune memory allocation, and then we need to tune I/O and physical infrastructure. When we tune I/O and physical infrastructure, again, that leads back into memory allocation. When we tune the resource contention in our systems. Then we go down into the underlying platforms, and that again leads back into tuning resource contention. So we see that this fine-tuning analysis process is quite a lot of work over time. And that's why we need to develop structures that will allow this to take place in a very periodic and as automated basis as possible. One of the important areas when dealing with fine-tuning analysis is removing noise. Imagine this. You're on a road trip, and inside the city, you're listening to a radio station. It could be AM or FM, especially if you're listening to an AM station. And as you get further out of the city, the station gets weaker, and you start to hear other radio stations, and you hear a lot of just static. And pretty soon, you can barely hear the radio station, and all the rest is just static and other badly tuned radio stations until you basically have to turn off the radio and put on your Bluetooth and listen to what you have on your phone or something like that. So that is the idea of signal to noise, right? The signal would be the radio station that you're listening to, and noise would be everything else. And when you're very close to the source, the signal is really strong, and the noise doesn't even come into your acknowledgement. You don't even know that it's there until you get further and further out. You start to hear more and more noise as the signal to noise ratio goes down. So that's what we want to do also in looking at analyzing our data. So let's look at this first bullet point and talk about removing noise. All of our acquired threats don't pose the same risk, do they? So as an analyst, you need to prioritize the alerts, allocate all your necessary actions that need to be taken depending on that priority, right? They don't all pose the same risk. So our signal would be the high risk, the highest risk, right? So remember we talked about statistics. You look at that bell curve, and in that bell curve, the ones that are the one standard deviation to either side are what we're looking at, the highest risk. Prioritizing those, and then getting rid of the rest as noise. If we prioritize those threats, it's going to eliminate all that noise and give us more actionable threat intelligence. And that prioritization of threats can help you or I, the analyst, to use our resources effectively and avoid false positives. One of the things we need to always keep in mind is our resources are limited. And with limited resources, one of the key areas we need to focus on is resource allocation. And if we're chasing the noise, we have resources dedicated to noise, then we can't take our resources, can't take enough of them and dedicate them to the actual signal, the actual highest risk threats. Right, so we want to avoid false positives. Fourth bullet point, to prioritize threats, the analyst can classify the threats based upon cost versus impact, right? Again, this focuses in on our resource allocation because we have limitations that we're going to impose. They're naturally imposed on any system. So if you look at cost versus impact, there's a little table here, and we have, for instance, low cost, general impact. That's green. Right? It doesn't take anything to do, and it really has a general impact. All the way to high cost, high impact, where here we have an APT, right? We have an advanced persistent threat, which is going to, especially if this resides on a critical system, in fact, most APTs on any system is a high threat. And so in this case, if you look at the red tile here, we're going to block it. We're going to work with our IPS. We're going to look at our NGFW, our web filters, our IPSs, our IDSs. Really, IDS is going to only alert us, so we really want to take action. So we're going to focus on intrusion prevention here, right? And then for things that are only a moderate cost and are in industry impacting, not for the company, focusing on the company, I might just work that into my SEIM, IDS, IPS. For the ones that are in the yellow tiles, we're going to investigate them. And for the ones in the light green, we're going to investigate when time permits. And for the low general, we're not going to do anything about it. So that is cost versus impact. Next, we want to look at logical fallacies. And as humans, we can very easily fall prey to logical fallacies. And what they are in terms of threat is errors. A logical fallacy is an error. It's an error in the implied logic. The vast majority of logical fallacies are going to either be completely human or they're going to be put into the system by a biased human, right? We tend to fall into these logical fallacies. And what happens in logical fallacy is the analysis that's based upon the logical fallacy is logically incorrect. And what it does is it defies the reasonable legality of the theory and certifies its unreliability for the utilization in threat intelligence. So essentially, when we have fallen prey to a logical fallacy, it invalidates that process. And depending on how far along we've come with that logical fallacy, we may have to invalidate an entire line of processes. What are the reasons for logical fallacies? Number one, misjudging the information value. And so sometimes the information value might have personal value to the person doing the judging and not specific value to the organization or to the threats that reside against that organization. So misjudging the value, irrelevant information gathering from feeds. And sometimes an analyst will just go afoot, go aside, go into a rabbit trail, go somewhere off that is not germane to the organization. It's irrelevant. The next is diverted focus on threats and leaving out critical indicators. Again, that logical fallacy takes us away from the critical indicators into territory that we don't need to be looking at. Too much data consumption for analysis, reducing precision in analysis. Again, this can be due to a logical fallacy about the amount of data that needs to be consumed. Last bullet point under reasons is failure to utilize the data in threat intelligence operations. It's ignored. We've seen this many times in history where previous to an invasion or to a war, there were indicators that something was going to happen, but yet it was ignored. So we want to make sure that we don't allow these reasons for logical fallacies to invade our threat analysis. Remedies for logical fallacies. Examine the information to see if it helps the analyst to detect threats. So pay attention to that information. Examine it. Ensure that threat intelligence is relevant to the organization and the threat landscape. I know for me, I have definite biases in terms of going through this type of information. And so, for instance, I have very strong attractors that pull me away from the straight information I need. I love quantum computers. I love AI. I like science and the latest theories and string physics and string theory physics and stuff like that. That has nothing to do very often with the threat that my organization is facing. However, it is so attractive that it could pull me off of the actual threat intelligence that I need to be looking at. What are some of your biases? Are you super interested in sports and then in one of the threat boards, somebody starts talking about football and all of a sudden you're pulled aside? So we have to make sure that we get rid of these biases as much as we can. Another way to remedy logical fallacies is to perform risk-based prioritization of threats. This really helps a lot because you look at it in just the pure form of how much is this going to cost my organization. And then we assign those higher risks and make sure that we know which ones to look at, to focus on. Next bullet point, use relevant context data, which allows teams to link the feeds to an organization and that organization's needs and make faster, serious decisions. So again, we're focusing in this case on the organization's needs. And lastly, ensure the feeds provide value for continuous threat monitoring, and analysis. So again, these all talk about looking at the numbers, looking at the data, looking at is what is required by the organization, looking at what threats are relevant right now and which ones have the highest risk. So we're looking at the numbers. We're focusing on that. We also have not only logical fallacies to contend with, but we also have cognitive biases to contend with. What's a cognitive bias? Well, it is a psychological phenomenon in which an analyst, or actually any one of us, any human, appears stubborn and biased towards their proposed theories, finding logical proofs to confirm their hypothesis and ignoring the evidence and theories of others that are contradicting their theories. So we have commonly known cognitive biases. I'll just go over a couple of these because, as you may have discerned, this isn't a psychology class. So we're going to talk about a few of them here. The first one is correspondence bias. What this does is we have a perceiver who's looking at a person, and they're inferring a permanent trait to that person based upon a passing activity. So for instance, let's say that somebody is very nervous when speaking in front of an audience, and the only time that you see them is speaking in front of an audience, and they're fidgety and they're sweaty and they stutter and they stammer, and that's how you think they are. But then when you see them in the rest of life, they are stable, competent, intelligent, and they never sweat a lot or get fidgety or anything like that. So we've seen a little bit of their personality, one small slice, and we've said that's who you are. Or we watch a television star on TV, and on TV they play a doctor, and they're logical, and they know how to deal with patients, and they're good under pressure, and the ladies like them, and then you think that that's how that actor is until you meet them in real life. You realize, oh, that's just a human. That is a correspondence bias. And the way we fight correspondence bias is through decision theory. Decision theory is looking at behavioral traits and corresponding them to specific decisions that made that trait. So for instance, I see somebody who is sweaty and nervous. Okay, what is happening right now? Oh, they are giving a presentation. All right. I see they're fidgeting. What's happening right now? They're giving a presentation. Well, it looks like all the traits that I've picked out are giving a presentation. Now let's use decision theory and go and see what else they do. Okay, they're in their office talking to employees. Wow, very calm. They are, getting coffee at the coffee maker, and they're talking to colleagues. Very calm, right? We can find out that, hey, looks like I had a correspondence bias with that person. We'll look at a couple more of these. The next one is confirmation bias, and some of the time you'll hear it called confirmatory bias or Mayside bias, and it's the tendency to search for, interpret, favor, and recall information in a way that confirms what you already believe. All right, so if you believe that the moon is made out of Swiss cheese, and that is what you believe, and you believe it firmly, then all the little circles that you see on the moon, that has to be cheese circles. If the moon is looking particularly yellow at night, well, that's because it's Swiss cheese. Well, people landed on the moon. Oh, we're going to throw away that information, right? The moon is in orbit around the Earth. Oh, no, it's cheese. It can't be in orbit around the Earth. So we are confirming our own theories and throwing out other data. And a way to de-bias or get rid of confirmation bias is through game theory, which is a mathematical technique that you can use to prove certain theories. And I was thinking about getting into game theory, but we'll not get into that. Look it up. Self-serving bias is another one too, which is a cognitive or perceptual bias where you have a distortion by the need to maintain self-esteem. So you'll see this sometimes when somebody is wrong about something, but they will not admit it. They will not admit it. Even though there is more and more evidence that they're wrong, they still won't admit it because they have a self-serving bias. So this can be fought through behavioral economics, belief bias through cognitive psychology, framing through machine learning, hindsight bias through human reliability engineering. Now, each one of these areas that we don't spend too much time on, I kind of stopped at game theory because there's quite a lot to each one of these cognitive biases and to each one of the debiasing strategies. And I would suggest that you take some time to look through all of this because it's very fascinating, at least in my very biased opinion. All right, now let's look at automating the threat analysis process. And one of the things that I talk to when I work with people or students who are studying infrastructure engineering, from switching and routing to working with servers and services and virtualization and all that kind of stuff, there are three things that I tell them that they must do. Those three things are automate, yeah, you guessed the third one, automate, right? We want to automate as much as possible because most of the critical tasks in an infrastructure are just too much for a single person to handle, so we must automate it. And so if we want to ease the threat analysis process, we want to automate it. Employ tools that help us to automate the process. Three things that we can look at for automation. Number one is threat analysis software. We can deploy that. We can deploy automated SIEMs, and we've been talking about some of this as we go through the class. And we can employ tagging the acquired indicators. This last bullet point, the tagging, will feed back into automation for our SIEMs and also for automating threat analysis software. So automation is extremely important. Next, we look at developing criteria for threat analysis software. So we talk about automation. We talk about automating your software, selecting SIEMs, and all this is going to assume that you have some type of software or you're searching for some type of software to help you automate. So in order to get the right software, you're going to have to develop specific criteria for selecting the threat analysis software that your organization is going to be using. So what we want to do is make sure that the tool that we choose includes the following capabilities. Number one, the ability to normalize data. Do you remember when we were talking about data normalization? One of the things that I said is that you're probably not going to be doing this with a pencil and paper or programming it yourself. You're going to be using a tool that'll run through these statistical analysis processes. So we want it to normalize data. Number two, we want to import and export threat intelligence. And when we do this, we'll be able to take the threat intelligence that we have and turn it into something that can be imported into our threat analysis software, and so that it can be used to protect our enterprise. Next, we look at the ability to structure unstructured data. Remember, we talked about that before too. We talked about unstructured data like emails and so on, and we want to make that structured so we can query it and make use of it in our automated systems. So we definitely want the ability to structure that data. Also to allow for intelligence processing workflows. And the workflow is actually a programmatic element. In many good threat analysis software, there's actually a GUI overlay, a graphical user interface overlay to the workflow process, allowing you to embed programmatic structures at different links in the workflow. So there are some very nice features for a lot of the software that does workflow processing. The next is the ability to link analysis with virtualization. And we come upon another very important point, because the fact is the vast majority of our resources, our services, are going to be virtualized. And so we need to make sure that we can link our analysis with that virtualization, and in fact through that virtualization. Next is to perform malware analysis with sandbox technology. So we want to be able, we talked about this many times too, we want it to be able to conduct that for us, to give us the tools to make that happen, to share and disseminate threat intelligence. And so with this, it goes to one of the other bullet points that we see later on, is to be able to create reports. But beyond creating reports, that's part of the dissemination and sharing, but we also want to be able to share it and disseminate it with other applications, other software, and other parts of the organization, part of the workflow. Next, we look at the ability to flexibly integrate with internal security mechanisms such as firewalls, IDSs, SCIMs, etc. So we want it to have a very good API or set of APIs and other capabilities that can help it feed right into those resources. You know what? What we're looking at here is a need to have an overall design. If you don't have good threat analysis software, you are in the process of setting up threat analysis, it's very likely that your organization may have an ad hoc infrastructure. What I mean by an ad hoc infrastructure is that your IDSs, PSs, your firewalls, your routers, your switches, your servers and services, your interconnections, and so on, they all come in different rings. Like for instance, you may have one engineering team that's designed your routing and switching infrastructure. Another engineering team that's designed and put together your firewall infrastructure with your IDS and IPSs. There's another team that worked on your SIEM and so on. So the problem with all of that is that they may not talk to each other in a way that will allow that threat analysis software to communicate with them in an overall overview. So what I mean by that is that you may have a series of routers that don't have appropriate output or input capability to work with your internal security information from another source. So sometimes it requires an entire redesign of your information systems from the bottom up. And when that happens, usually this is going to have to be done very logically using project planning over a period of time to budget that and make sure that during the upgrade there aren't any gaps in coverage. So what happens is, in this third to the last bullet point, flexibility to integrate with internal security mechanisms such as firewalls, IDSs, SIEMs, etc. We may find that in searching for your threat analysis software, you cannot find one that will integrate with all of that infrastructure. In that case, it's time to redo an overview of your infrastructure so that you can easily integrate all of it with your threat analysis infrastructure and be able to thwart threats as they come through. Again, we want reports. We see that second to the last bullet point. The last bullet point, to generate performance, operational, and value metrics. We take those metrics. Those can be part of the reports. Those are going to guide us and show us how well we're doing, where we're having issues, where the threats are coming from, all that. We get good metrics. That's going to help us in the future with taking on other threats. Next, we have employ advanced threat analysis techniques. You've heard me say many times that we need to consider AI. We need to consider machine learning in threat analysis. And this is where we talk a little bit about that. And so an analyst can employ advanced threat analysis techniques like machine learning. This helps us to fine-tune, helps to ease our threat analysis process and enhance it. So on our second bullet point, we see that it was conceptualized from pattern recognition. And this is true. I remember back in the old days when we thought that facial recognition would never really work because the human mind did it so fast and would never have computers powerful or fast enough to do facial recognition. And now we can do it real time and query databases as people walk by to see if they're a criminal or something like that. And so the early days of neural nets, all the way to genetic algorithms and hidden Markov chains and so on, make the pattern recognition really become a quick and easy process for computers today. And now we use that same evolutionary process to bring that self-learning capability into threat analysis. Also, we see that with advanced threat analysis techniques like machine learning, that it learns from patterns in the data to perform effective computation of unsolved patterns and gaps in traditional analysis methods to generate reliable, efficient reports and decisions. So when we look at the outliers, remember we talked about that bell curve, right? We have the most risky threats in the middle, and we focus on those. One of the interesting things is we can take machine learning algorithms and look at the data that we threw away and maybe even find interesting patterns in that data, and maybe we can loop back around and put some of those back into the higher risk area depending on what our machine learning algorithms find. Machine learning enables automated threat analysis to detect organizational threats effectively. So yeah, obviously we get more effective detection. Moving on to the last bullet point in this section, with a growing variety of data and computational capabilities, machine learning is emerging as one of the great tools in computing and analyzing the bulk data and patterns in them, producing faster, accurate outputs and effective, complex data analysis. And let me augment that by saying that as we are experiencing a technological growth at an exponential rate, that machine learning is going to get smarter and smarter, faster and faster, and better and better. And one of the things that you'll notice when using machine learning and narrow AI is that the leaps in capability are going to happen seemingly overnight. So for instance, you may have a product that has a very good machine learning backend that has been able to raise your capability by 5%. And then with an update, you see that it raises your capability by 25%. And then with another update, it's 85%. I mean, these usually are going to be in these huge leaps that you see in a very sharp curve. And so that they can take you by surprise. So one of the areas to look out for in terms of software procurement is another type of bias, in that we expect the software that works to be the one that's going to stay relevant for our organization for a long time. In this era of exponential change, especially in the area of software and computers, we find that we're going to see changes that look like they are going by very fast. So for instance, you'll see a change in the effectiveness of a certain algorithm. It's 5% better because of machine learning. And then later on it'll be 25% better, and then 85% better. It tends to leap and catch people by surprise. And here's one of the issues with software, is that you may have version 3.0 of the software. It's integrated, it's running well, it's giving you results, it gives you reports, it feeds back into your SIEMs, it does great with your firewall and intrusion prevention systems, and they move to version 3.3 and 3.8, and you stay with it all the way through, and then version 4 comes out. And since version 3 is still working great, you ignore version 4. And then version 5 comes out. And since version 3 is still working, you ignore version 5. And many times the only reason organizations upgrade to version 5 or version 6 is because it will no longer run on their infrastructure. So they have to upgrade their infrastructure, and with that, upgrade the version. This is something we want to avoid. Here's why. Because as we are in this exponential time, sometimes a version change in software will up the game so much that you cannot afford not to upgrade versions. So don't ignore new versions of threat analysis software just because the old version is working. Right? So look out for that bias. I've seen this many times throughout my years of IT. Now let's go to features that we find with machine learning threat analysis. Number one, augmentation of human capability. And yeah, we need to go beyond human capability. I'm just one person. I cannot take care of the entire enterprise. And also, I don't think fast enough to pour through a terabyte of data in a few minutes. Next is identifying insider threats with anomaly detection. And what's better than an AI to look for anomalies? Immediate spotting of data breaches, to be able to scan all of the important data areas of your organization and find that you've had a breach before that breach has been too big or acted upon or the data's been exfiltrated. That is great, right? Faster threat hunting and investigations, efficient SOC operations, all of these can be enhanced by machine learning. Supervised learning, where you have to put the software into a learning mode and sort of hold its hand through it. Unsupervised learning, where you just let the software loose to look for patterns and to learn and train on your systems. Semi-supervised learning, where part of it is supervised, the rest is unsupervised. And reinforcement learning, where when there is a positive result, that's reinforced back into the learning architecture to make it better. So advanced learning techniques, advanced techniques using machine-based learning, very good for threat analysis. So one of the best tools in this mix of tools that we see coming out recently is Microsoft Azure Machine Learning Studio. And it's a machine learning based data analysis tool. And when we say tool, that word is a little bit too small. It's actually a suite. It's an environment that you use with fully managed cloud services that allows a threat analyst to build, to test, to deploy, and share predictive analysis solutions on your own data. And so if you have Azure, it would be worth it to have a look at this. If you are exploring using machine-based threat analysis tools, it would be worth it to have a look at this tool. Are there other tools out there? Yeah, have a look, do some searches on Google. You'll find that there are other threat analysis software out there that are machine-based, machine learning tools, but this is one of the best. Next, we look at another advanced threat analysis technique, which is cognitive-based threat analysis. When you look at the term cognitive, what does that put into your mind? Yeah, your mind, right? It's about thinking. An analyst can employ advanced threat analysis techniques like cognitive analysis to fine-tune, ease, and enhance the threat analysis process. So what is this cognitive analysis process? Well, it's an advanced data analysis technique. And you're going to be using computation, so computing machines, and making use of their human-like thinking capabilities. One of the areas that we've seen that is a growth area in the next few years is this entire area of cognitive-based computing. And if you look around, you'll see that there are a lot of neural processors around these days, and there are a growing number of them, where you can incorporate these types of tools into your normal computational methodologies. In fact, you can even buy, there are even cognition sticks that have neural-based processors on a stick, and other entire platforms or cloud-based platforms that are very, very useful. And so with cognitive computing, we use it for data analysis, for large amounts of structured data, but especially with unstructured data. It can help structure that data or analyze that data. And cognitive computing integrates numerous applications to bring out the actual required context and find intelligence that's hidden in the large quantity of collected bulk data. And so this kind of takes us back to what I was talking about before with noise and signal, right? And the ability to tune out the noise and find that specific signal requires a high degree of cognition, and a lot of these cognitive computational techniques are very good at pulling that information out. And if you're looking at cognitive analytics, it'll allow the intelligence technologies that you're looking at, working with, to connect to your data sources and process them, help with effective decision making. And one thing to keep in mind is cognitive computing is not programmed, right? It evolves by learning based upon the data and then giving you a result. And a lot of times you'll hear these cognitive algorithms, they're trained. You feed the data in, they learn by doing. If you look at some of these cognitive systems, you'll find that they learn by being trained, right? Just like you would train your dog or your cat. Well, never mind, you can't train your cat, but you can train your dog. And that's the same thing that happens with some of these cognitive-based programs. And so you don't actually sit there and put in information, but rather they're programmed, they evolve. The collected data is their playground, and they learn to get results based upon what they've learned in the course of that analysis. All right, so here's another tool. This is one that Cisco puts out. It's called Cisco Cognitive Threat Analytics. And this is made to help you detect, respond to sophisticated clandestine attacks that are already underway, or maybe they're trying it. They're in there, they're attempting to establish a foothold, a presence in your environment. Well, Cisco Cognitive Threat Analytics can help you with that. Tracking data extraction, there's a domain generation algorithm, exploit kit tracking, track HTTPS requests, command and control communications, giving you real-time indications, preventing data exfiltration. Fairly easy setup in the integration, and also really helping you to find and filter those genuine threats. So this is a very nice tool. I've used a lot of Cisco tools, and they've really come a long way in the presentation and installation and setup of their tools. So yet another one I would recommend looking at. All right, so now let's look at understanding threat intelligence evaluation. What we're going to look at is strategic, operational, and tactical and technical threat intelligence. And lastly, in this section, we'll look at threat attribution. So now let's talk about threat intelligence evaluation. And as an overview, what we see is that we're going to be looking at threat intelligence products. And the evaluation that we're going to be looking at is going to be there to make sure that threat intelligence or the analysis of that threat intelligence meets the original design and requirements of the organization. So after we conduct this evaluation, if it meets the original requirement, then we can use that intelligence to get that information out, disseminate it out to the intended users, or in some cases, the intended uses of that information. But if it doesn't meet the original requirement, then the analysis is going to analyze any of the causes for the failure, and then we're going to go back into another loop of fine-tuning of that information and analysis in order to make sure that it meets the original requirement. So we start with an evaluation and we check to make sure it meets the requirements. If it doesn't, we loop back through fine-tuning. The evaluation of threat intelligence enables the analyst to land at accurate and precise conclusions regarding these threats and threat actors. So without evaluation, we can go off the rails. We want to make sure that we stay where we need to be and our conclusions are justified. And lastly, we can take that evaluated threat intelligence and use it by analysts or security professionals or top management to help us go back and design and modify and deploy further security mechanisms to help us in the future to avoid future attacks for the organization. So evaluation is an extremely important part when we're dealing with threat intelligence. Next, we look at, in terms of threat evaluation, is we need to evaluate the gathered threat intelligence based on the intended objective. And most of everything we do in terms of automation, in terms of evaluation, in terms of threat gathering, in terms of processing and modeling, all of that is going to be based upon what the objectives of our organization are. And if they are not, then they're going to fall outside of the scope of what we need to be doing, either that or our objectives need to be evaluated. So assuming the objectives are where they need to be, we need to compare and evaluate any gathered intelligence with the objectives of our organization. What objectives do we have in terms of threat intelligence? What is our planning in terms of threat intelligence? What did we come up with when we planned this entire project for our organization? Does the intelligence match with that? If not, then we need to reevaluate. So after we've completed this analysis process, then we need to deliver this threat intelligence to the intended audience. Who is it? And to the stakeholders. Who are they? And so we have to take that information and get it packaged and ready to deliver. And that's called a deliverable. There are 3 types of deliverables that we want to look at. Number 1 is external deliverables. And this is where we're gathering information specifically for sharing with threat groups and communities. So this is going to be information that's usually going to be stripped of any types of information that would lead it to compromise our own organization, or it's going to be fairly general depending on the type of threat group or community that we're dealing with. So the next one is internal deliverable. And this is going to be going to top-level management or third-party clients that are intrinsic to our threat intelligence process. The next type of deliverable is an actionable deliverable. And so we'll develop ROCs that have our details of threats and deliver them to our teams who are going to take that information and integrate it into some type of actionable intelligence. And it's going to go right along with our existing security measures. It's going to add to them, and it's going to be used to help us avoid future threats. Furthermore, in the area of threat intelligence evaluation, we have strategic, operational, tactical, and technical intelligence. And this is something that we've talked about several times, so I won't spend too much time on each of them. But first of all, when we're talking about the evaluation of strategic threat intelligence, this is information or threat intelligence that's going to be evaluated in a way so that it supports our senior management or officials who are part of the decision-making process. And there are some qualities and parameters that we need to look at in terms of threat intelligence when we're talking about strategic threat intelligence. Number 1 is accuracy. We want to make sure that the intelligence that we're providing is accurate, that we understand the degree of impact, and we're looking really for a high degree of impact. And also we want timeliness. We want to make sure that any of the strategic threat intelligence that we present is timely. It's germane to what's happening right now in our organization in terms of threat intelligence. So we see strategic. Next, we look at operational threat intelligence. In this case, it's going to be evaluated to allow us to have insight about upcoming attacks. So rather than being timely and accurate in terms of current attacks or current threats, we're looking at upcoming attacks. We're looking at predicting attacks using threat intelligence. And so when we evaluate operational threat intelligence, it helps to give us insight about our vulnerabilities and the possibility in the future of an attack that would exploit those vulnerabilities. Next, we look at evaluation of tactical threat intelligence. And for tactical, we have information that's to be evaluated in a way that helps the analyst assess methods of information feeds that are employed in, and here's the key word, the key terminology, defensive mechanisms. So now we're on the defense. So with strategic, we're looking at help with the decision-making process, making it timely right now, and having a high degree of impact. With operational, we're looking at the future. We're looking at upcoming attacks, predicting an attack, and getting insight about current vulnerabilities and helping us to be able to make sure that we don't fall prey to attacks based upon those vulnerabilities. And then with tactical, we're looking at defense mechanisms. So we get recommendations from security team members to help upgrade defenses. It's going to help us to analyze and evaluate any rare, unseen, or previously used methodologies of attackers and make sure that all of our defenses are up and ready to thwart the attack. All right, so we have strategic, the now. We have operational, the upcoming. We have tactical, defensive, and then we have technical, which is preventative. So what we want to do is prevent the attack. We want to make sure that no attack is successful in being executed. So this is about the prevention of specific attacks. So we want to have effective usage of inexpensive, commercially acquired feeds and analytical platforms that are going to allow us to prevent attacks. So we're going to take the information from these threats, looking at attacker methodologies, resources, etc., and use technical threat intelligence to prevent attacks. Next, we look at the idea of threat attribution. So once we go through all the threat analysis, go through the evaluation process, we look at the results that we achieve, and then what we can do is attribute the threats. So who did it? Who do we want to attribute this specific threat to? So there are several different types of attributions. Number one, group attribution. So this deals with attributing based on common group associations of multiple malicious actors and their attack methodologies. And so what we'll say, for instance, is when we look at the intelligence data, that it looks like we have a specific, it could be a crime group, organized crime. It could be a nation-state threat actor. It could be a lone wolf. What is it? Group attribution. Right? Next, we have a campaign attribution. And what we're going to do is attribute, based on the malware that we're looking at, some type of campaign strategy. And so we can say that we have a group attribution of a specific crime group in a specific country that is running a new campaign, for instance, to get money from some type of process or product. We can call their malware a product that will extort money somehow from the attacks that they're perpetrating. The next is intrusion set attribution. And what we want to do is look at specific patterns. We're looking at the intrusion patterns, and we are attributing a specific type of attack to those patterns. Next, we look at true attribution, and this deals with the identification of the specific person, the identification of the specific society or a country of sponsoring a well-planned and executed intrusion or attack on its target. So who is the organization? Who is the country? Who is the specific person who we would attribute this to? And like I mentioned before with a group, a subset of group, when you look at true attribution, that's a subset of group. Another subset of group is nation-state attribution, right? So we're looking at what nation is the threat actor, which is the nation state that is conducting the operation. So true nation-state, intrusion set, campaign, and group attribution. And as you can see, a lot of these are very often mixed with each other. Okay, now we move from threat intelligence evaluation into the area of creating runbooks and creating a knowledge base. We're talking about developing the runbooks. We're going to talk about creating the threat knowledge base and organizing and storing cyber threat information in that knowledge base. So that brings us to developing runbooks. Organizations need to be able to have a very well documented process as to how they responded to any threat. And this is called a runbook. And so they need to prepare a detailed runbook to document those responses, to document the process that was used, including all of the details starting from the identification of the threat to the post-incident activity. So this runbook is not only important for documenting what happened for posterity's sake, but it's also important for planning for the future. It's also important from a legal standpoint and even from a fiduciary standpoint in terms of the CIO, CEO, CFO, etc., who are going to need to have this information. So here are some of the advantages of documenting the response using a runbook. Number one, we can identify solutions of threats efficiently. We want to see what the solutions that we came by were. And if they're in a nice knowledge base, we can easily search out information about what happened last time to help prevent the same thing from happening in the future. Number two, eradicate guesswork and uncertainty while handling the threat by following an efficient and effective incident response and change management process. All right, so no more guesswork. We want to handle these threats as they come in an organized, step-by-step manner. Number three, appropriately escalating threats to the right support group. And what we'll find if we examine our runbooks is maybe at some points that was not done correctly in the past, and having a runbook can help us to look into the future and make sure that our escalations work appropriately. Number four, assign resources efficiently to handle the threat. We already talked about resource allocation and know how important that can be. Number five, accumulate data quickly to escalate the diagnosis of incidents. And so if we have a nice organized process, it's very easy to accumulate the data we need and then diagnose what's going on. Number six, efficient threat handling leads to increased user productivity. If we are able to handle a threat quickly, we can get users back online or make sure they don't ever have to go offline. And number seven, demonstrate the maturity level of the threat intelligence management program. So if ever there is an audit, which there should be periodically, of the threat intelligence program, going through those runbooks will show how you handled it and show that it's at a high maturity level. Or it may show that it's at a low maturity level. Both of these we need to know. Now let's look at some considerations for developing runbooks. So what information should you include in runbooks? So for instance, we want details about threats, the source, frequency, impact, affected data, failed controls, and maybe if it was unintentional or malicious. Which one was it? Because we do have internal threats many times that are unintentional. So those are things that should be included in the runbook. Why should an organization care about runbooks? Because there is a great potential impact on the organization in terms of revenue generating units, in terms of efficacy of users. We want to improve that. Influences in productivity and timing and level of tolerance. All of these help us to care about runbooks. And the next one we look at is, what should the organization do with runbooks? You have this nice little runbook, or actually it's a lot of information, right? What should we do? What actions need to be taken by whom to progress through an investigation? And if we're looking at containment, or if we're looking at planning, that's what we do with runbook, right? We see what the actions that we need to do for containment and planning. And so runbooks are extremely important. If your organization is not using a runbook, then you can actually be in jeopardy as an organization on a legal basis. So whether we're looking at the CTIA, the Threat Intelligence Analyst, or the CISO, at both of these levels, there should be a runbook involved. So what do you want to do to customize a runbook? What you want to do is develop your new runbook based upon the highest priority intelligence needs, using a threat prioritization process. You want to also include a summary of threat information based upon what the identified threat was, why the organization should even care about the threat, and how the organization should and will respond to the threat. Also, for the runbook, in terms of customization, we want to customize the response and escalation process for the runbook. So how was it escalated? What was our specific response to this threat? And then update a review history and assign a title holder to the document. So the title holder would be the CTIA or the CISO, whoever it is that we are dealing with in terms of this runbook, creating this runbook. Next, we look at creating an accessible threat knowledge base. This is something I've been talking about for a while, which is having a good knowledge base. And having a knowledge base, having that repository of knowledge, is extremely important in threat intelligence and in managing IT systems in general. And it helps you to document what happened, share that with the entire team to create a threat collaboration environment. That's what we really want. And so what's going to be included in that knowledge repository? Things like pivoting, right? We want to take the data threat and all the activities and contextualize it. Content structuring. We want to store our intelligence in a structured format, right? We want to structure it so it's easy to use and manage. Data management. We want the ability to modify or delete past intelligence or irrelevant data. A protection ranking, which is the ability to apply protection ranking to sensitive data to make sure that any highly critical data is not shared with untrusted partners. And what you can do with protection ranking is you will take a specific knowledge-based entry, and for a very good knowledge-based system, you'll be able to tag it, and then when you tag it, it will say what can or cannot be done with this particular leaf in your knowledge base. Like, for instance, cannot be forwarded, cannot be emailed, is private, requires password, things like that. Next, we look at news feeds. So the ability to provide real-time news alerts and briefings and reports. And so the actual knowledge base may have a front face that has a news feed of things that are currently happening. Evaluating performance, the ability to evaluate past security metrics. So you just be able to do a quick search in the knowledge base and you see what the past metrics are. And again, that brings us to that bullet point, searchable functionality. We want to be able to query to get those indicators. All right, so we see here that the threat intelligence analyst is querying the knowledge repository and is able to interact with security operations, vulnerability management, incident response, data owners, and control where that data goes, and pull out news feeds and so on. So having a knowledge base is extremely helpful. And so let's talk about the organization and storing of the cyber threat information in the knowledge base. So organizations, what we're going to do is collect all that threat information. It's going to come from a wide variety of sources, open source, external sources, commercial threat feeds. It's going to be based upon the usage of threat indicators. So it's going to be necessary to store all this information and organize it into a knowledge base. And so what's going to be stored in this knowledge base? Let's just look at it very quickly, an overview of what's going to be stored. The source of the threat indicator, the established rules for using shared threat indicators, date and time when it was collected, lifetime of the threat indicator, whether the attacks are related to a threat indicator from another source or another industry, whether the indicator is associated with a common weakness enumeration, or CWE, or a common vulnerability enumeration, CV, or a common configuration enumeration, CCE, or a common platform enumeration. What is it based on? Threat actors, who were they? The threat actor aliases, TTPs by the threat actor, associated threat actor motives and intent, different types of individuals targeted by the associated attacks, systems targeted in the associated attacks. If you stop and look at each one of these bullet points, you'll find that this can be a lot of data. And very often what's going to happen is as you fill out this knowledge base, the information in the knowledge base is going to be collected from multiple sources. Like for instance, some of the knowledge base is going to be created automatically by your threat intelligence software, your defense software, etc. Other entries in the knowledge base are going to be made by your staff, your other CTIAs, your other CISOs, and other cybersecurity staff. And very often it's going to be a combination of the two, where you're going to get an automated entry that's going to be fleshed out by part of your staff. So having that knowledge base, extremely important. Having a run book for your organization, also extremely important. This brings us to an overview of threat intelligence tools. We're not going to take a huge amount of time going through these tools, but they're important to know because they are extremely useful. Starting with AlienVault, we'll also look at IBM X-Force, we'll look at Threat Connect, we'll look at SurfWatch, look at autofocus and a scattering of other tools. It's very important to get your tools right when we're talking about threat intelligence. So let's look first of all at AlienVault USM Anywhere. And so this is a threat detection tool. It's great for incident response, compliance management, and extracting threat intelligence. It works across the cloud, works with on-premise, also works with hybrid environments where you have both. And it's supported by the Open Threat Exchange that we've talked about much earlier in the course. And it's really great for global threat identification. Next, we look at IBM X-Force Exchange. It's a cloud-based threat intelligence platform. And again, you're going to consume, share, and act on threat intelligence. We've seen many different tools from IBM in this class, and they just make a very good set of tools that just help out a lot with threat intelligence. We see Threat Connect. It's designed to help analysts understand the adversaries. And one of my favorite here is workflow automation, and helps with threat mitigation. This again makes use of threat intelligence. SurfWatch. A lot of my clients make use of SurfWatch. It's a very good threat analyst. It's a SaaS product, and it helps with strategic delivery of operational threat intelligence to identify your adversarial opportunities for attack, and then help you to proactively mitigate your cyber risks. Autofocus. Again, this is one that some of my clients use. This is contextual threat intelligence services that helps you accelerate analysis, correlation, prevention, works again with workflows. And by the way, any of these products that don't talk about workflows, virtually all of them have workflows, workflow capability. So that's one other thing I appreciate about them. And there are many other tools that you can have a look at here that are used by quite a lot of organizations. And beyond the tools that you see here, there are many other tools. And your organization might be using threat intelligence tools that aren't listed here. That does not mean that they're not worth it. If your tool is working the way you need it to work, and it meets the criteria that we've been talking about in this class, then the tool that you're using is the right one for your organization. If the tool that you're using in your organization, or the suite of tools, the set of tools that you're using in your organization, were put there for political purposes, then very likely you'll want to reevaluate the tools according to what we've been talking about in this class. Well, that brings us to the end of this module. We talked about concepts related to the analysis of collected data. We talked about data analysis types and techniques, a detail regarding threat analysis and the threat analysis process. And we talked about techniques for fine-tuning the threat analysis process. And we've also talked about some of the tools that need to be used and the idea that it's extremely important to have a runbook and a knowledge base in your organization. In the next module, and that's going to be the last module, the CTIA, we're going to discuss various threat intelligence reporting and dissemination techniques so that you can be much better in making sure that your organization understands threat intelligence.